好，各位专家、各位来宾，大家下午好。很高兴大家能参加下午由两个工程中心所主办的未来互联网基础设施研讨会。今天我是在这儿做一个简单的 host， 然后介绍一下。首先呢，先介绍一下这个日程。我们今天很荣幸邀请到在这个域名在 IP 领域方面的专家来给我们分享他们在这个领域比较热点的问题吧。然后呢，之后呢，我们会有一个先是 David Conrad 是 ICANN 的 CTO 来给我们介绍在跟域名领域的潜在发展方向。然后是 Vixie ISC 的创始人，也是2014互联网名人堂的入选人。他会介绍一个 One Namespace， 就一个名字空间多种接入方式的这样的一个 topic。然后之后呢，我们会有20分钟的一个茶歇。之后呢，我们会请到这个 Andrew Sullivan 是现任 IAB 的主席，他给我们介绍名字标识物联网的体系架构。之后呢，有请这个马岩老师给我们介绍在未来互联网的技术跟创新的应用。那最后呢，我们留出足够的时间给大家有个 open 的这样的 discussion。好，现在首先有请主办方致辞。
非常高兴。其实我已经第2次致辞了，上午已经做了一个致辞。但我觉得今天的会议非常小，但是我觉得非常兴奋。我们在两个中心在准备这个会议的时候，随着万物互联的这个时代的来临，特别是中国提倡这个互联网+，给我们带来了产业的巨大的一个机遇。在这个产业机遇的过程当中呢，我们可以看到我们对互联网基础设施的这个要求呢也更加急迫。作为第一大互联网国，我们应该更多的去对全球互联网能够发挥更主要的一些贡献和作用。所以在这里头，我们今天的会议也体现了一个世界一个互联网一个梦想。另外一个我们今天呢也非常荣幸的是一个 multi-stakeholder， 我们也有政府的主管部门，那我们也有学术机构，我们有运营商，特别是我们有很大的中国的3大互联网公司，今天代表都出席了我们今天的会议。我们希望通过这样的一个公开的讨论，把我们在过去，我们在应用方面我们非常的去发达，但是我们在互联网基础设施的这个过程中，因为我们是后加入互联网国家，我们在这方面呢目前面临着极大的一个机遇。我们希望呢深入的去和 ICANN、IATF、IAB、APNIC 这样的组织呢能够进行紧密的合作，能够把我们对我们在应用方面的一些发展，能够在互联网基础设施方面能够有进一步的贡献。今天上午我们也听了很多的这个主题演讲，也是我们很多的随着我们的这个应用，我们的万物互联的时代，对网络的依赖、对安全的依赖更加的迫切。那么我们今天这个会议呢，我们想提供这样的一个平台，让大家呢能够畅所欲言，能够去讨论一些下一步我们网络做的如何更加强壮，更加的去富有弹性，更加满足客户的需要。大家今天上午的主题演讲讲了很多，那我在这里呢也是深表感谢。作为主办单位之一呢，我在这里也不特别介绍我们采用互联网的模式，不特别介绍我们的主要的领导，我们所谓很多权威的专家。那我们主持人呢会一一的进行这方面的介绍。我非常愿意在这里呢跟大家一起来分享，我们开启了一个新的时代，来进行在互联网基础设施方面的创新、推动和发展，实现我们的梦想。谢谢大家。
接下来有请下一位这个会议主办方毛伟域名工程中心主任北龙中网董事长。
各位贵宾各位专家，非常高兴呢，我们代表这个域名工程中心来欢迎各位的光临。在去年呢，我们也曾经主办了这么一次研讨会，也邀请到了这个海外的顶级专家来一起来探讨互联网基础设施的演进和发展的一个未来。 我们这个互联网社群呢，应该还是受益匪浅。这个互联网的快速发展呢，它是离不开安全稳定的互联网基础设施的一个坚实的支撑。互联网产业的健康发展也需要一个高效、可信的互联网的基础设施。互联网的广阔的应用前景也必将推动互联网基础设施的这样的一个发展和演进。同时呢，全球互联网治理模式的这么一个演进，也会使得我们的互联网基础设施的一些协议和管理进行重新的一个架构。中国呢，作为一个互联网的一个就是一个用户群的一个大国，我觉得呢，中国发展到今天呢，理应呢在互联网的这个基础设施的这样的一个领域里面呢，为世界互联网的发展呢做出贡献。因为通常来说，我们更多的是关注的互联网的这个应用层应用层面它可以带来直接的一些收益。但是呢，互联网的真正刚才所说的安全的发展、对应用的支撑、对未来互联网的治理架构的变革和演进，都是需要互联网基础设施层的这个支持。但是这个层呢，它通常是一种非盈利性的、公益性的所以我们讲呢，中国发展到今天这样的一个地位以后，也应该为世界互联网的发展做出自己应有的一个贡献。今年呢，可能这样的一个考虑我们今年呢，在这个也是继续在这个3届专家委的这个指导下，我们举办了第2届的互联网基础设施研讨会，也邀请到了相关的一些权威专家。我们也是希望呢，在这个领域里面呢，跟大家一起来进行思想的碰撞，能够推动这个行业的这个发展。我们这个域名工程中心本身呢，它也是长期以来在这个从事互联网域名地址方面的研究我们也希望能够在这个里呢，能够获得各位专家的帮助一起来推进我们互联网基础设施的发展和演进谢谢大家。
下一位嘉宾将是 David Conrad 请允许我几分钟介绍一下David Conrad 呢先生呢是 APNIC 的这个 founder 创始人之一，也是首任CEO， 然后呢在 IP naming 方面有卓越的贡献，然后呢现在是 ICANN 的 CTO， 主管这个ICANN 和域名方面的政策、技术方面的制定。今天呢，他将会为我们带来关于未来跟名字服务器潜在的发展方向让我们有请。
Hello, everyone. Thank you very much for inviting me to speak here today. Quite honored to be able to speak to this workshop on infrastructure, and particularly talking about the potential root server futures. And I should probably preface this talk with a sort of a statement that this is probably stuff that you all already know, but I thought it'd be useful to sort of level set so that there's a general understanding. Everyone is on the same page. So a quick agenda, how we got here to the current state that we're in, a very brief overview of the current status of the root server system, what problems are we trying to solve, and then some possibilities of the potential futures of the root server system. So I actually found a website, a guy named Sean Donald, who's been doing stuff with the internet for many, many years. Actually maintains this timeline. It unfortunately only goes up to 2002, so just when things started to get very interesting in the domain namespace, Sean found better things to do with his time. But this is a timeline of sort of how the root server system was generated. Initially, in May of 1984, the first test server was set up at USC ISI, the University of Southern California Information Sciences Institute, where John Postel was I guess, grad student and a professor. In 1984, in July, SRI-NIC was the SRI, Stanford Research Institute, NIC, Network Information Center, were the folks that actually were the coordinator for the ARPANET at the time. And those two addresses were used for Srynik, and that was the A root server, the equivalent to the A root server today, 10.0.0.51, and the MILNET address 26.0.0.7.3. That sort of gives you the flavor of how the DNS first started being deployed. It was primarily in support of the ARPANET and the MILNET, because that's what the internet was in those days. In '85, ISIB, October, ISIC, and then BRL, that's the Ballistics Research Lab, the U.S. Army. In 1986, John Costello actually solicited for more root servers, and around that time there were the 4 root servers you see there. Jeeves was the software that was written by Paul Macapetras to implement the DNS protocols, and then that was the first instantiation of Bind as one of the root servers. Don't want to read all of these because we could spend a lot of time on this, but let's see, the next, in 1991, nick.norju.net was the first non-US based root server. That's was the research and academic network in Norway. Around that time was when the Internet was created as a NSF-funded project, and we began the migration of everything over to Internet, which was run by Network Solutions, who currently runs the A and J root servers. In August of '95 was when we did sort of the massive renaming. Prior to that, each individual machine had the name associated with its organization, so Srynik or .nils for the U.S. Army root servers. In August, we figured out that if we put them all under rootservers.net, we'd actually be able to free up space for 4 additional root servers. They were J, K, L, and M. J and K were operated by Network Solutions, L and M were operated by ISI. Eventually, K moved over to London, operated by RIPE NCC, and in 1997, M was migrated over to Tokyo to be operated by Y. At that time, J stayed with Network Solutions, eventually to be operated by VeriSign, and L stayed at ISI until ICANN was formed, and then transferred over to ICANN. So the current status, as I'm sure everyone knows, there are 13 root server letters operated by 12 organizations. 3 of those are non-US organizations across 466 different sites in dozens of countries. I didn't have a chance to actually count the number of countries. The root is DNSSEC signed. It was signed in July of 2010. And that means that there's no way you can make a modification to the root zone without it being detectable by a validating resolver. ICANN's role in the context of the root servers is to provide a venue where the root server operators and other interested stakeholders can discuss root server related issues. The Root Server System Advisory Committee recently restructured itself and is now has a caucus that is more general than just the root server operators themselves. It should be reiterated that ICANN in no way controls the root servers. We obviously operate L, the one root server that was originally operated by ISI, but we don't have any mechanism, in fact no mechanism exists to control the root servers, and that's actually considered a feature because it prohibits what's called capture. There's a great concern that some group of bad people could eventually capture the root servers and then be able to control the contents of the DNS. Since the root server system is structured as it is, there's no single common thread other than an interest in making sure the DNS operates among all of the root server operators. So looking at what problem are we trying to solve? There are a number of issues that I've heard being discussed in the context of the root server system. One is the distance, the amount of time it takes to actually talk to a root server. This is actually particularly important for negative responses, because negative responses always go up to the root, unless they're negatively cached. Another issue is root server overload. For example, when a denial of service is being targeted against a root server, it is possible to degrade the service of that root server. Network partitioning. Since there are not root servers everywhere on the planet, it is possible to segment the network such that you do not have access to a root server. This could be bad for a number of reasons. And then there's also the inappropriate management of the root zone itself, making changes outside of accepted policy for the root zone. So going into each of these problems directly, distance to the root servers. So these graphs were actually computed by a network monitoring company called Thousand Eyes, based in San Francisco. And what they've done is they've looked at the latency that was encountered trying to reach a root server from on the left side from different ISPs, and on the right side from sort of the average across a bunch of measuring sites within the country. The ones in red are the ones associated with China. So China Mobile and China Telecom were averaging, when this was done, and this was, I think about 5 months ago, we're averaging about 60 milliseconds. CERnet was averaging about 16 milliseconds, 1.6. And the country average was also around 60. Root server overload. So I sat there and did a bit of the math. Right now, the L root server is currently receiving approximately 25,000 queries per second. And if you sort of assume the load is the same across all of the root servers, it's not. Some get less, probably some get more. L is sort of unique in that it is one of the most widely distributed of the root servers. It's currently in 150 different sites, including, I believe, a couple here in China. But you know, on average, let's just, for sake of argument, say that every one of the root servers gets about 25,000 queries per second. That works out to 325,000 queries across the entire system. The current average query size is about 200 bytes. That works out to about 520 megabits. And the worst case response is 1,500 bytes, and that is if you take the scenario where we're actually rolling the root KSK, the response from the root server will be about 1480 bytes, I believe. And that works out to about 3.9 gigabits. So in theory, at least, you could, with a couple of commodity servers running commercial off-the-shelf software, you could actually just slap in some 10 gigabit Ethernet and put it in IXs and cover the entire root load of the internet. However, that is the sustained query rate, not the peak query rates. The graph on the right there is a snapshot of the denial of service attacks that have been ongoing on the internet, not directly to the root servers, but just in general. And those are graphs of millions of denial of service attacks over month time frames. And most of those are flood attacks. Some are DNS amplifications attacks. It's interesting that the denial of service are actually decreasing over at least 2014, although the generic TCP SYN flood attacks appear to be becoming more popular these days. So the implication of that is that we can't obviously account for the steady state. We have to actually engineer for the worst case. Network partitioning, obviously that's an accidental break, accidental or malicious break in connectivity. that can remove access to a root server. The picture there is of the repeated breaks of fibers that are going across the Indian Ocean and up into the Mediterranean. In many cases, they're caused by anchor falls. The anchor goes and just slices the cable when the ships anchor in the wrong place. The implication for root servers, if a root server is partitioned off, then it'll continue to operate, continue to serve queries to the folks who can reach it until the zone data goes stale. If the clients are partitioned out, then you essentially have a failure to resolve periods. So inappropriate management, the examples that I've heard in this problem space are serving different answers depending on who's asking the question, or out-of-policy changes to top-level domains. For example, removing the top-level domain or changing the name servers associated with the top-level domain. This turns out not to be a problem that can be solved with the root servers if DNSSEC is actually used. DNSSEC would require both, to solve both of these problems, to have a different trust anchor configured, because once the zone data is signed, it cannot be modified without being detectable as being modified. The root servers are a publication mechanism. They don't have editorial control. If you're running a root server, your ability to actually change the zone is non-existent if you assume DNSSEC is deployed. Currently, last figures I saw were about 30% of DNS queries are actually being validated right now. So, looking at possibilities, there are a couple of options that we can look at improving the root server system. We can add more servers, and there are two ways to do that. One is by adding more instances, another is by adding new letters. Or we can change the rules under which the root server system actually operates. There's a draft that I term unowned anycast, and then there's mirroring the root zone. Good. So, adding more instances, there are at least 4 root server operators. There may be more, I'm not entirely sure, that are willing to add instances pretty much anywhere. ICANN's root server. We are willing to deploy instances pretty much anywhere as long as you can support the machine. It does generally requires entering into some sort of agreement with the root server operator, mostly just to agree not that the instance won't be used to modify the root zone. One advantage of this is that it doesn't require any changes to the DNS protocols at all. It uses BGP Anycast, so you're basically just dropping in a new machine, announcing a prefix, it starts getting queries, everything else is normal. When you add more instances, you can reduce latency. One of the challenges there is identifying where instances should go. There have been a number of attempts to sort of do that algorithmically, but none of those have succeeded. And basically it boils down to whoever is willing to host the instance and has the infrastructure to support it. It can reduce the global damage due to denial of service attacks. An instance will localize traffic. The downside of that is if you are sharing fate with one of the name servers that is near a source of traffic, you will continue to be routed to that source even though it's no longer responding until the BGP announcement is pulled. That means that you individually will experience the denial of service attack, but the rest of the system as a whole will continue to be able to access that root server. And obviously, if you're deploying more instances, you can reduce the risk of network partition, at least for folks who are outside of that partition. Looking at adding more letters. There is this protocol limitation of 512 that I'm sure everyone is quite familiar with. There have been a couple of suggestions on ways of addressing this. One idea is to get rid of the root servers.net domain completely, just move everything into the root. So A dot would be the A root server, B dot would be the B root server. This could save a small amount of space. It's unclear how much that would actually help. Another idea that has been suggested in a couple of places was to perhaps, get rid of all the root glue in the additional sections. The disadvantage of this is that it will require additional lookups, additional latency to actually find the address of the root server when the glue isn't in the additional section. Then, of course, there's the idea of increasing the response size. There have been a number of different approaches that have been suggested to increase the response size. One way would just be to assume that fragmentation isn't that big of a problem. Another would be to move to TCP. The real challenge with any of these potential options is to figure out who would run the new letter, how you decide, and who makes the decision. As I mentioned, ICANN is not in control. We do not cannot dictate, it's not our role. We coordinate, that's all. We provide a venue where stakeholders can get together and figure out what is in the best public interest for the internet as a whole. And then, in some cases, there are a couple of documents that RSAC has written that describe, for example, the service expectations or the statistics that the root servers should collect. But it all depends on the cooperation, the volunteering of the root server operators. And in reality, adding a letter doesn't really solve a technical problem by itself, because you still have to implement that server somehow, right? You would need to deploy instances somehow, and if you're deploying instances, then you're back to the original, the previous solution. So, looking at changing the rules, there's draftly DNS scaling root, which I'm guessing Dr. Vixie will be discussing, perhaps. This is actually a solution that can be deployed today. It actually probably has been deployed today. It challenges, it does run the risk of potentially stale data, because if someone misconfigures the zone transfer to pull down the root zone data, then the zone data will go stale. It also, personal perspective, I have some concerns about some network management challenges. One of the downsides of unowned anycast is that if you're trying to figure out where that network, where that information is coming from, it can be a bit challenging to actually locate where the source of the traffic is. Another option, draft Kumare DNS op root loopback. This one mirrors the root zone into the resolvers. So in this option, resolvers would be configured to pull down the root zone and answer directly. You can do this today. In fact, my understanding is that a large number of, well, not a large number, some number of large ISPs actually do this to improve the performance for their customers. Similarly to the previous draft, there is a risk of potentially stale data. This one is less, in my view, less risky in terms of network management, because it's simply the resolver process, not playing with any cascades and routing games. Both of these options would require an improved zone distribution system. Right now, I believe 5 of the root servers are open for zone transfer. ICANN makes the root zone available for FTP. We also have a couple of zone transfer servers that are not the L root server. The L itself does not allow zone transfer. We created 2 zone transfer servers for the root zone. But clearly, if, for example, the draft Kumare is actually going to be accepted, that means every resolver on the planet could potentially be doing a zone transfer, and that would be a lot of traffic. Fortunately, there are these things called content delivery networks that the amount of data that's in the root zone is very small compared to, say, your average movie streaming out of Netflix. So the challenges associated with distributing that are not that large, and I've actually already been in discussion with a couple of CDNs to see if they'd be interested in supporting a larger amount of zone transfer. And then there's the question of statistics and monitoring. One of the challenges in the root server system as it exists today is that it's actually quite difficult to get a comprehensive picture of everything that's happening on the root servers because each of the root servers is operated independently. If we move to any of these solutions, that will greatly make that problem much, much harder. So both of these drafts can address the latency concerns because it moves the responder, the root server, into the user's ISP or the resolver operator space, so the latency would presumably be equivalent to the latency that they get talking to their ISP, period. Both drafts can mitigate DOS. In the case of draft Kumari, the resolver would be the target of the denial of service, and it's relatively easy to stand up another resolver if that becomes a problem. Both of these drafts would also affect the partitioning problem. So other possibilities. So in my view, adding more instances tends to address the latency to the root server overload and network partition concerns. It doesn't require any protocol changes and no policy development. All of those seem like positive to me. The mirroring the root and unknown anycast solutions are a little more complicated. It does require a little more work on behalf of the folks who are actually operating the servers. But the advantages to those solutions, may be worth it in certain circumstances. DNSSEC itself prevents the inappropriate management problem. That makes the assumption that the output of the global multi-stakeholder management process as it exists is considered appropriate. So far, I believe that has been the case, and I don't think that'll change in the future with the transition of the stewardship of the IANA functions. And also it's worth noting that DNSSEC means that you don't have to care where you get the zone from. You could get it from anything, from a memory stick that you find in the parking lot to any ISP or anything like that, because the root zone itself can be validated. So adding more instances does not solve the sort of the non-technical problems, the sort of the more policy-related problems. But then you get into a question is, how many root server letters do we really need? And as is the case, almost all of the root servers are already anycast, and by definition, because of DNSSEC, the contents of what they are serving is the same, then the advantage of having, multiple root servers becomes a little more questionable. And there are potentially some advantages in even reducing the number of root servers. One of the challenges that we're facing in the development of the plan for rolling the root zone's KSK key signing key is trying to keep the response size when we're in the middle of the roll and we have two keys, the old key and the new key, trying to keep that from fragmenting and causing problems. It may be, and I have not explored this, may be that if we had fewer root servers, then we wouldn't have these size problems. So there are undoubtedly other problems that I have not covered that are worth exploring. And there are also undoubtedly other solutions, other possible ways of addressing these problems. The key is to ensure that the consistency of the root zone remains the same, that we have a single namespace, because if we go beyond having a single namespace, then things get a little complicated with name switches. So, I will take questions.
You can wait here. OK， 稍等一下啊，就是每个环节都会有提问的环节，然后这有一个移动麦，然后那边有一个立麦，大家对这个跟服务器啊，包括这个 IANN 呢 transition 在这个技术方面呢，可能有这个考虑，都可以提的相关的问题。我觉得今天是一个难得的机会，咱们能够关注在技术这方面的这样的可能的变化。我觉得这是每一个从事技术人员、从事互联网技术工作的一个比较难得的机会吧。好，机会交给大家。
Richard from BI here. Firstly, I think the fragmentorium is really a problem here because as far as I'm concerned, fine, we will not do anything with SMP2B package, so you get the fragment here in IPv6, it was an SMP2B package here, and fine, we will not do anything with it, it will ignore it, and the response will never be received. Okay, so my question is that, as you say that I guess we first want to add letters because we want to add the availability for the users can find root name server here, and we start to add letters because we do not have any tag there, and now since we have any tag here, do you think we still need that many root name server? I mean that many letters? Thanks.
Please speak in Chinese again. 中文。
OK， 我是BI 的高尔夏。首先我认为IPv6 分片是一个问题，因为现在 bind 的实现上说，它并不会处理你的 SMP2B 的包。一旦你的 IPv6 的应答被分片了，那个 SMP2B 包回来的时候 ，bind 是不会处理它，会直接忽略了它。那么你的这条应答是不会送给你的那个用户的，你的用户只能等待超时再重新问一次。第二个是我向David Conrad 先生提了一个问题，就是说，我们最开始增加这个我们的自我的那个根服务器的原因，是因为我们想让更多人都访问根服务器，来增加这个它的可用性。那么我们最开始是因为选择去增加这个根服务器的名称，是因为我们当时并没有 Anycast 任波这种方式。那么现在我们有任波这种方式了，我们是否还真的需要现在13个这么多的根服务器呢？
So on the topic of bind and large packet responses, one of the things that we're doing in the design team for the KSK rollover plan is trying to understand the implications of the large response size, and some of the work that Jeff Houston has been doing with his the APNIC test infrastructure that uses Google Ads to run tests in everyone's browsers, at least everyone who can see Google Ads. It seems to indicate that the impact of fragmentation may not be as scary as we once thought. However, there does seem to be a problem with fragmentation and IPv6, for one, and two, it seems that bind in particular appears to favor IPv4 for reasons that we're not entirely sure about. So since Jeff is Australian and Mark Andrews, who is the I guess lead architect of bind these days, is Australian. Perhaps they can get together and understand each other. They speak Australian, I can't understand it. With regards to the number of root servers, speaking personally, I've recently begun to question the rationale. Having a diverse infrastructure is obviously important. Having a decentralized infrastructure is obviously important. One of the questions that I would have, if I could go back in time and start over from the beginning, is what would be the best way of developing a diverse, decentralized architecture. However, with that said, the root server system has been in operation now since 1984. And if you actually go to that URL, Sean Donnellan's page, it's actually, it shows many of the problems that occurred during the growth of the DNS. But since you know, the DNS, since the internet became more popular and the DNS sort of stabilized, the root server system just works. And that has a lot to say for it. And if it does work, you know, do you want to go and muck with things that work, particularly something that is as important as the root of the DNS. It is almost by definition the most critical resource on the internet today. So I would be hesitant to do significant changes, at least in a non-testbed environment. You know, and maybe one of the things that the Yeti DNS testbed could look at are exploring some of these questions in the context of the testbed.
好，谢谢 ，Thank you。还有问题吗？ I personally has a question. Please forgive me just using Chinese. 我的问题其实也是源自于之前的一个观察，就是现在关于 IANN transition 的这个话题，里面很多是 policy 的一些讨论，而我们想知道，就是从技术的角度，我们想知道这个IANN transition 这一件事情成功或者失败，或者是取决于是 policy 的policy 来决定呢，还是技术还会起到一个作用？这是一个问题。二一个问题就是说，如果它的这个 transition 到了一个按照一个方案进行下去，它的这个系统框架，这个 root server 系统框架会不会相应的有所变化？
So with regards to the transition, the technical impact of the transition, I'm actually, one of my roles at ICANN is to be in charge of the technical implementation of the transition. So the technical implications are, one, to remove the US government's role in root management changes right now. That role is, you can actually see what's on, what NTIA's role is in root zone management. They've published a document that describes what their role is. It turns out that role is actually, now with the automated root zone management system, essentially a no-op. They have never turned down a change request. So one of the technical bits is we have to change the software to get rid of NTIA. That's actually simple. Any other change depends on how the transition moves forward with regards to the root zone maintainer function and the relationships between ICANN and VeriSign, and that stuff is still up in the air. Excuse me. But in answer to the second part of your question, you know, from a technical perspective, the root zone management is actually really boring.
Yes.
All the interesting bits occur in the policy realm. Once it actually gets to the IANN function itself, then it is, you know, it's editing a zone file, and the question of you know what potential technical changes result from policy. Right now, it's the current plan is that there will be essentially minimal change. There will be a removal of NTIA. The current plan is that NTIA will not be replaced. There will, you know, the role NTIA theoretically performed was verifying that ICANN followed the documented processes and procedures in order to implement the root zone change. That authorization role was felt by the CWD, the folks who are working on the transition in the policy realm, that role was no longer necessary. So that will go away, and ICANN will talk to VeriSign directly instead of going through NTIA to have the changes implemented.
Thank you.
Sure.
Wesley from ZMS. As the member of RSEC, we noticed that RSEC, RSEC caucus has published 2 documents. One is about the expectation of the operation, another is about the measurements of the operation. But I noticed that in your last slide, you mentioned that adding more instances might not be able to solve the question about how many root servers actually needed.
Sorry about that. Do that again. There, this slide, yeah.
Yes. How many root servers do we really need?
Yes, right.
I wonder if it's possible if we could ask our SEC office or our SEC to draft some expectation and measurement from the end user side, because the current expectation and measurement that goes from the open side. If we could have another, parameters about the expectation from the end user, then might help the local community to at least for them to measure the root service performance from their perspective.
Right.
And then to give their requirements about the root server. Maybe that will not answer the question how many exactly, but at least they will provide the local community a tool to check.
Right. I think whether or not RSAC is asked to do that is an interesting question. The graph here, this one, is doing, I think, essentially what you're asking, right? Measuring from the end user perspective the performance to the root servers. This actually, I think, would be an extremely valuable exercise to do, because it would help to identify where additional root server resources are actually necessary. Right now, we basically sort of guess. We don't really have a whole lot of hard data. Back in the late 90s, there was a research project that NSF, National Science Foundation in the US, had commissioned to try to identify the best place to put root name servers. That project never actually completed to my knowledge. And we've sort of since then sort of just gone on and done what we normally do, and people make private arrangements and talk to root server operators and they deploy things. But having an analytical model, where we can say, the latency here is, 2 standard deviations off the norm, thus that explains why it would be really good to have an additional root server resource at that location. And that makes a lot of sense to me personally. And as ICANN's CTO, I can say that is something that I'm interested in looking at.
由于时间的关系，我们要进行下一位专家的演讲。Thank you for your speech. And 我们在最后还会有一个 open discussion 公开的讨论，有一些问题呢，大家可以留到最后的半个小时，我们还可以仍然跟 David 一起讨论这样的热点问题。好，下一位演讲者是 Paul Vixie 他是 ISC 的创始人，然后呢，他在域名，包括尤其在跟服务器上的演进方面有一些独特的一些看法跟实践。那今天呢，他是很遗憾不能到现场，但是他可以远程接过来，然后现在把时间交给他。Hi, Paul.
Hello. Can you hear me?
Yes. Can you share your screen with us? Oh, you can say hi to us right now.
Hello. Hello, everyone.
All right.
I cannot be there with you.
Okay. So it's your turn. Yeah.
So I'm going to start my presentation now by sharing my slides.
You can share your screen from your side.
Yes, I'm working on it.
Okay.
Okay. I'm sorry, this is Windows, so it takes a little bit of extra time. Okay, can you see my slides?
Oh, perfect. Go on.
Okay, so I am Paul. Oh, wait. You have to mute on your end. Okay. So I am Paul Vixie, CEO of Farsight Security. I'm not speaking for Farsight today, but that is my day job. So first let me say I agree with everything that David Conrad said, and I've known David Conrad for more than 20 years. That's an unusual thing for me to say, but really I hope everyone takes to heart his observations about what the problems are and what the different solutions are. I'm going to be speaking about a proposal that is related to the first internet draft that he mentioned, Scaling Root-Lee. I am a co-author of that draft. That draft is out of date, and it reflects an approach that we have become convinced will not work, but a related approach that is already in wide use will work, and so we will be updating that draft shortly. With that, let me begin. DNS is like a great collective illusion. It is an artificial reality that only exists because we all believe in it. Our belief makes it true. And let me explain why that's so. Every internet host, for example, each laptop and smartphone in the room with you or in the world, has a chance to choose what recursive name server it will use in order to do its DNS lookups. So although the DNS is certainly usable, hold on. Is it still working?
Yes.
Okay, sorry. So although the DNS is directly reachable from most of the end user devices like laptops and smartphones and servers, that's not how they tend to use it. And the reason is for performance reasons. We put a server very close to each device on the internet, and that server is called a recursive DNS server. And it is really up to each device to choose which one it will use. Most often you will use the one assigned to you by your phone company, by your ISP, by your IT department. But that's not necessary. You can choose your own. And so the complete set of responses that will come from the recursive name server that you select is what will determine the content of the internet from your point of view. And as David mentioned, it is common for ISPs to modify DNS for their own purposes, usually by intercepting negative responses and replacing them with positive responses for advertising insertionism. And that would be an example of you getting the internet as your recursive DNS provider wants you to see it, and not as it really is. Now furthermore, every one of those recursive servers has a choice to make. It has to choose its root DNS servers. When I say root DNS servers, that was the topic of David Conrad's presentation. These are the servers that are the ultimate source of knowledge for the DNS. I say ultimate because they know what are the top level domains. And in China, the top level domain you're most familiar with is .cn, or perhaps the IDN, the international DNS version of that, which would be the symbol for China. But there are about 250 other country codes. For example, .us is the United States. That's where I live. That's where I'm speaking to you from. There are also some non-country codes like com, very, very popular domain for com, net, org. There are all those top-level names. Those are the ones that the root name servers know about. And there's a frequent misunderstanding about root name servers where it's believed that they know everything about the internet. And indirectly that is true because they know about the top-level domains. But as David said, the total size of the root zone is incredibly small. So if a Netflix video of a movie that was 1 hour long would be maybe more than 1 million times larger than the root zone. It's a very small amount of information, but that information is what makes the rest of the DNS reachable. And so when you select a set of root name servers, you are also selecting what set of top-level domains will be reachable to you. And we have seen it happen that certain ISPs decide to add some local top-level domains that are only reachable by their customers. This almost never ends successfully. In other words, every attempt that I've heard of this trying to happen has failed, because if a name will only work for customers of a single provider, then that name is very small compared to the DNS as a whole, which is reachable by the whole world. Nevertheless, the recursive servers choose their root DNS servers. And the most common choice is to use the servers that are operated by IANA. IANA is the Internet Assigned Names Authority, names and numbers, and it is the IANA duty is the principal function of the ICANN Corporation, which David Conrad represents today. And so the IANA is where all of these names are known, it is where they are changed, it's where they're maintained. It is the ultimate authority of truth for what is on the internet and what are the names that are usable on the internet. But you can reach whatever set of root name servers you choose, and there are many enterprises that operate their own root DNS servers simply by copying the IANA data. So they have a complete set, but then they might add a few top-level names that are only usable inside that enterprise. And this is controversial, but an enterprise has total control of its own IT environment, and therefore no one really can tell that enterprise what to do and what not to do. They can have whatever DNS they want for their employees. You can do this at the ISP level. You can also run a root locally. For example, I have for a very long time a name server on my own laptop, but I am a DNS researcher, and so that's probably very unusual. It's also possible to innovate further, but that innovation will be reflected by the choices that your recursive DNS makes. Now, if everyone chooses a recursive DNS server that in turn chooses the IANA root servers, then that's a choice. That's a set of choices which leads to the collective illusion that there is an internet and that the internet has a consistent namespace. But I wish to emphasize that this is optional. This is a choice that we are making because it is the rational choice. It is the right thing to do. It is in our own best interests. It's in our own selfish best interests. It's not a duty. It's something that we do because it helps us. Unilateralism in DNS, where you try to modify the namespace for your own reasons and for your own benefit, but at the expense of other parties, is unreliable. You can do this in many hotels, many ISPs. A lot of coffee shops do this. They modify the namespace. But if you don't want that to happen to you when you're in that hotel, then you can use a VPN. And so that unilateralism is a statistical device. It will help you for some of the people that you can impose your terms on, but it's not a guaranteed choice. You can't absolutely ensure that someone will see only the DNS you want them to see. And indeed, a few years ago, the United States Congress debated a law called SOPA, which would have caused US ISPs to show a smaller version of the internet for the purpose of protecting copyrighted works that were being infringed online. And online infringement is a real problem, but many of us went to Congress and told them that this would be unreliable, and that people would just use VPNs and they would bypass all of this, and that it would not help, it would not solve the problem. Now, as David Conrad said, DNSSEC deepens this cooperative aspect, because if you have a DNSSEC validating recursive name server, then it cannot be fooled. If an ISP inserts new names, then it's very likely that the validating name server would detect those insertions and would treat them as forgeries and would ignore them. And yet DNSSEC itself is a choice, because it is up to you, up to each of us, as to which validation key we're going to use. So, I want to mention IANA was once John Postel, who was a great man, and we miss him very much. It has passed on to becoming a function, a contractual function assigned by the US government, currently assigned to ICANN. ICANN was created for the purpose of having this function assigned to it. So now we're talking about a transition to try to get the US government out of that role, and we expect ICANN to continue. Nevertheless, the function, IANA as a function, is exactly as David Conrad described it. It is a cooperative process where the people who use the internet, the people who build the internet, can meet at ICANN and determine what will be the policies of IANA, including whether or not to create more top-level domains. So this is not a company, this is not a country, this is not a political power that has the ability to unilaterally impose terms on the world. It is rather a reflection of what the world wants done to the world's internet. So please think of yourselves as small parts of the IANA. Now the IANA root name servers are diverse. They are worldwide. There are hundreds of them. The operators are independent. They are not under contract, other than, I think, in the case of VeriSign and ICANN themselves. There's no contract that requires that this service be provided. So the providers of these services have their own reasons for providing them. And we're lucky, as David says, the root name service has been the most reliable service that any of us can think of. There has never been a time that someone on the internet from the earliest days in the 1970s has tried to look up a name and has failed to do so because no root name server was able to answer them. There may have been a retry, there may have been a slight delay, but there was not a failure. And I can't think of anything in the world that is at 100.0% uptime for almost more than 3 decades. So it's a very reliable system, and we believe it's because of the diversity of these volunteer operators. The IANA root name server system has DNSSEC. They have a very secure method of keeping their keys and using their keys to re-sign the data periodically. And all of us who use this data have the option, and I have taken this option for myself, of validating the information we receive to make sure that it really did come from the IANA servers, which means that it was signed with the IANA key. So this is a very effective system, and it's working. And the coordinators of the IANA root name server system are ICANN itself, the US Department of Commerce, and VeriSign. And they work together to make sure that the data is accurate and timely. And they have done a very good job. It is that second coordinator, the US Department of Commerce, that is probably going to be removed or replaced soon. Now this system is intended for internet scale production. That means that all of the billions of people on the earth that are using the internet are depending on this system. And so far that's worked. Now I wish to describe another system called Yeti. This is an experimental root name service project. The coordinators include myself for TISF, BII, who is your host today, and a technology consortium in Japan called WIDE. And this is an entirely experimental system. we precisely mirror the IANA namespace. So we never add or delete any TLDs. This is simply a mirror copy of the IANA DNS namespace. It's likely that we will be about 1 hour late with changes. So if IANA makes a change, it might take up to 1 hour for us to reflect that change. Usually it will be less, but 1 hour is the worst case. Now again, the servers are diverse, they're global, and they're volunteer operated. There is no contract that requires someone to operate a Yeti server, and no one gets paid for doing so. Each operator serves for their own reasons. Now, like IANA, we have a DNSSEC key, and so in order to use the Yeti system, you must use our validation key, because obviously we don't have the IANA signing key. We cannot sign our version of this root zone using the same key that IANA uses. But we have to sign our own version in order to change the name servers. But again, I wish to note, we never change anything except the name servers. This is not an attempt to add or delete any names. The top-level domain namespace will be exactly the same at all times. But the most important difference is that this system is intended only for internet-scale science. So this is exactly the system that is required in order to answer some of the questions that David posed in his talk and that came up during the questions and answers. And I'll get to some of those later. The fact is, we don't have an internet-scale test bed right now on which we can do the type of science that is required to inform policy about, for example, should we rename the root name servers, as David was mentioning. All right, moving on. There are reasons that you might not want to use the IANA root name servers or the Yeti root name servers. And one of the reasons is that you might not have one that is close to you. You might not have one that is inside your city or even inside your country. And that makes it an external dependency. You are counting on somebody to operate this server. They're a volunteer, you have no contract with them, you have no way to ensure their performance. And because of some outage, perhaps a ship will drag an anchor, as David was describing, and will cause an outage between where you are and where the closest server is, that might cause you to be unable to reach that server. So having an external dependency is seen as a business risk. There's also a surveillance opportunity for outsiders. If you are sending your root name service traffic to far away destinations, you're sending it to servers that are not located in your city or in your country or in your ISP or perhaps in your enterprise, that means that somebody who can watch the network traffic outside of your network will be able to see your packets, and they will know a lot about what you are doing because they can see those packets. Now, because of these two risks, it is common now. It is maybe not an everyday occurrence everywhere in the world, but it is hardly, I think, rare for people to decide to run their own root name server system that are not internet visible, and that therefore prevents you from having an external dependency, and it avoids the surveillance risk. So I'm going to take the unusual step in a moment of telling you exactly how to do this. It is so simple that I have a total of 11 slides today, and I'm going to use 3 of them to explain how this works, because I really do want to make it clear that there is a solution to the problem of both external dependency and surveillance, but also scale. David Conrad mentioned, what if the root name server is DDoSed? What if it's under attack? Will you be able to reach it? Will you perhaps share fate with it? There are many problems that can occur, and there are common solutions to this that are in wide practice today. But I do want to first define what I mean by an autonomous network, which is any cooperating set of hosts, DNS servers, and root servers. Remember I said that it's a collective illusion that creates the reality of a root name server, of a domain name system, in fact, is the collective belief that certain root servers have an answer and that they share a key and that the recursive servers all use those root servers and validate with that key and so forth. So any cooperating set of users and providers and root servers is able to form their own autonomous DNS root service network. Now this could be a single host, as for example on my laptop, this all happens on what I call my loopback network. And so in that case, I, by myself, represent an autonomous network, which is a cooperating set of the things I've said. Again, I'm a DNS researcher, and probably very few people do as I do. Nevertheless, you can also do this on any LAN, which is to say any house, small office, home office. You can do this for a university campus or an enterprise. You could do it inside of an ISP. You could do it inside of the country, or you could do it regionally. So the size of your autonomous network can be as small as a laptop or as large as a continent. It only has to be cooperative, because you cannot force somebody to use it. It has to be something that you create for the benefit of those who choose to use it. Now, IANNA's content is openly available. David mentioned that he thinks that there are at least 5 root name servers that are open to zone transfer. I'm very proud of FRoot, which was for a long time my root name server. We were the first ones to be open in that way, and I now see that FRoot has competition. I think that's wonderful competition. Let me say though that there are a lot of people who fetch that data, and Yeti would be an example. I've written here on the slide ORSN, but Yeti would be a better example of someone who fetches the IANNA data periodically. In our case, in the Yeti case, we fetch it once per hour, and just change it. We change that data a little bit to make it reflect our servers instead of the IANNA servers, but we preserve all the other data about TLDs, top-level domains. And I am aware of any number of mid to large enterprises who operate this way, and even some research networks. I believe that CERNet, for example, operates a system similar to this. And I do want to say that ICANN has a slogan. It's important to have some philosophic principles behind any company, and their principle is one world, one internet, and I think that's a good principle. But we wish to expand it by saying that it's one world, one internet, and one namespace. So it's not just that there's one internet. We want there to be a single namespace where if a domain name works anywhere in the world, that name will work everywhere in the world, and it will always mean the same thing, no matter where you are in the world. There is a controversy to creating alternative sets of root name servers, because normally you do that for the purpose of modifying the namespace. I wish to strongly characterize all of my efforts and all of the Yeti efforts that BII is involved in as not being that. We are not trying to take over any kind of controlling role of the content of the namespace. It will always be the IANNA naming. So there are 3 parts. If you wanted to do this inside your university or on your laptop or for an autonomous network that you thought you could build cooperation in, then you'd have to do what we did at Yeti, and there are 3 parts. First, you have to find some root name server operators and find out what their names and addresses will be. You have to make a root zone signing key and decide on some kind of a key management regime. How often will you change the key? And you do have to change these keys, they become stale. You have to come up with a set of distribution master operators. These are the coordinators usually, and they also have names and addresses. At the top of that file with the ones that represent your circle of cooperation, and re-sign that modified file using your locally created DNSSEC key. And finally, you give this server to your root operators using the standard DNS protocols of notify and incremental transfer. So this is extremely similar to the IANNA workflow, except that they don't have to strip off their own signatures. And this is what the distribution master servers do. So in the IANNA system, this is what VeriSign does. So VeriSign has a distinctive role in root zone publication. Okay. Last, finally, turn it on. You start that root zone processing, which I described in part 2, and you start your root servers, which were discovered in part 1, and then you reconfigure the cooperating recursive servers to use that hints file and use that key, and you're done. You want to do some daily monitoring and so forth, but that's it. That's really all you have to do. And your system can grow to be as large as it needs to become. I don't think that I myself am capable of building a system that billions of people could then depend on, which the IANA has done. But I could certainly build a system, and I've helped with BII and WIDE, I have helped to build a system called Yeti that will be global in scale, although it's likely to only have a few thousand participants because it's meant for science and not production. So, I do want to explain the Yeti testbed because that is some news since the last time I began talking about any of this. We want to do some science because the internet governance policy that happens inside of ICANN, and I guess right now is happening inside of the US Congress when they decide whether they should allow a transition of the IANA functions contract, it must be informed. You can't just say, I don't want a certain policy because it relies on technology that doesn't exist or wouldn't work. I think that we should try various things, and we should publish objective, repeatable science about what we tried and what we learned in order to inform these decisions. So I'll give you 4 quick examples of some experiments that we're planning to do. We want to know how often DNS keys can be replaced. I can tell you that right now, the DNS key that we're using, the key signing key, was created once, years ago, and there isn't really much confidence that it could be changed because it has been hard-coded in a lot of places, and we don't think that a change would be reflected by global updates. In other words, if we change the key signing key right now, using only the processes we know, it's likely to break the internet for a lot of people. We change the zone signing key every couple of months, but with Yeti, we're planning on changing that key signing key once a month. And we're going to try and change the zone signing key once a week, or maybe not those times exactly, but it will be that often. We're going to learn exactly what you can do about rotating these keys and replacing them. We've already begun, and this experiment is to find out whether an IPv6 only root name server can work. In other words, if there were no IPv4 reachable servers, then are there any hidden IPv4 dependencies? IPv4 is the old internet, it's the legacy internet, and I realize we're using it today for me to talk to you, but it is nevertheless old. It is more than 30 years old, and it has run out of addresses, and we are switching. So now we want to know, what if we switched? What would happen if we really discarded the old internet? That's not something that the production system can easily try, because if it does have problems, we don't want to create problems in the production server. So IANA is not going to try this out, whereas we can, because we're only allowing people to do science with this network. We would also like to know if root name server operators could be replaced. We've had the same set of people serving the root, and David Conrad's presentation gave you the history. Some of these people from back into the mid-1980s. That's a long time, and I think that they do a fine job, but that it may be that someday one of them would like to stop, and we don't have a process for that. Part of the reason we don't have a process for that is that we don't know what the impact will be, technically speaking, on the people depending on that root name server. So Yeti's going to find out. And finally, we'd like to answer the question I heard during the Q&A session after David Conrad's talk, which is, how many root name servers is enough, and how many would be too many? I personally do not think that the 512 octet limit is all that serious. I think that we treat it as if it was some magic number, and that if we break it, then everything will go to hell in a handbasket. Maybe that's so. We're going to find out, because we're going to be inviting 20 or 25 root name server operators using names that don't compress well. We're going to have gigantic responses, and we're going to watch what happens to the network, and we're going to see what happens with fragmentation, with TCP. We're actually going to measure it. Those are 4 experiments that we know we want to do, but I want to stress that this is an open experiment. We hope that others will come and join us. We hope others will come and want to run servers. We'd like the existing root name server operators to decide that they'd like to also run servers for Getty, because we know they're good at it. But we would also like network researchers to come to us with experiments and to propose experiments that we can schedule and we can coordinate through this open global testbed. So the fact that I only have 4 ideas listed on this slide should not give you some idea that we're only going to test 4 things and then stop. We're going to run through the end of 2018 and then stop unless we have some reason to extend it. But in that time, we have room for a lot more experiments. So please do bring us your ideas, bring us your servers, subscribe your test labs and even your houses and your laptops to our service, and give us some test traffic and help us with this science. So let me just end by saying the proposal is controversial. Many people believe that the root zone is the same as the namespace. I don't think so. I think that the namespace can be represented by more than one root zone, and that they should all be treated equally for the purpose of determining whether top-level domains exist or they don't. As long as they are all showing sort of complete respect for the namespace process that is part of IANA and ICANN, I believe that it's fine to have a lot of different root name server systems. And it's a good thing, because we already have a lot of root name server systems that all copy the IANA data into their own autonomous networks. In other words, I didn't invent this. I'm giving you a picture of how a lot of people in the world are already using the internet, but they're managing their external dependencies and their surveillance risks by running a close, well-managed, well-protected private root name server system. This proposal has one extremely negative side effect, which is that it's hard to measure. If you have a lot of private root name server systems, then you don't really know how the internet's being used. And so for the purpose of informing policy, it might be very useful, for example, to know what top-level names are being tried, but which fail. Because that will tell you that if you allow somebody to create a new top-level domain having a very popular but currently not existing name, then it's going to pick up a lot of existing traffic, and that might be seen as disruptive. So right now we're able to do that type of measurement using the IANA root name servers because they are all willing to cooperate on sharing their measurements. But once you have a lot of independent private root name server systems, we don't believe that they are all going to share their measurements and to help inform the policy. So this is a problem. But let me tell you that Google and OpenDNS already do this. Google never sends a query to an IANA root name server system. They fetch the zone and they incorporate it. Same thing for OpenDNS. And so we already have tens of millions, if not hundreds of millions of people whose DNS lookups are not measurable by the IANA root name servers because we never hear queries for them at the IANA root name servers. So again, I wish to say that although this is a downside, it is not new. So thank you very much for your time. I'm sorry again that I could not be there personally, and your comments and questions are welcome.
Okay. So there's before the question and answer the session, I want to speak the background. 请允许我先介绍一下，就是我们在组织这个会，在为什么会选前2个有关于跟服务器的一些问题。因为从事技术研究一段时间来，发现在跟服务器的一些问题上，掺杂了很多的因素，有政策的，有技术的，还有一些国家的一些博弈。但是呢，作为技术人员来说，我觉得真理越辩越明，一些这个互联网发展的历史原因，一些技术的障碍，或者一些这个政策的因素影响，我觉得可以今天能有幸请到这个顶级的专家来给我们分享，我觉得这是一个很好的这样的一个方式去澄清一些这样的概念和里面的一些运作的流程。所以呢，也很有幸今天有这样的机会可以提出我们自己的一些看法或者一些观点出来。好，现在的时间留给大家。如果有任何问题可以举手，还有后面有麦克。Okay, Paul, can you hear me?
I am here.
Okay, because it's my job to convene this conference, so the workshop. So I come up with a question. Firstly, I will introduce this question in Chinese. Do you mind? 我第一个问题是想问 Paul 先生，是关于这个 IPv only， 因为我们下一代互联网工程中心呢是从事 IPv6 还有下一代互联网的技术标准测试工作，所以在和 Paul 先生在做这个 Yeti 这个 project 的时候，我们就首先想到了在 V6 过渡期间，尤其是在只有 V6 的环境下，不依赖 IPv4 的环境下，现有的系统，尤其是这种很重要的这样的跟服务器系统，是否还能够 survive， 是否还能够存活，会有什么技术的挑战？这其实是我们当时拟定的一个题目。所以我想向 Paul 也提一个问题，因为在我们的研究和方案测试方案中还在想怎么去 design 这个实验，所以我的第一个问题是在 IPv6 only 环境下还有什么新的机会或者挑战会发生在现有的这个框架？
So, the big challenge with IPv6 only is that it has a different way of doing IP fragmentation than IPv4. And so when you try to send a large packet in IPv4, if you send a packet that is too large, then any router in the middle of the internet is able to break that packet into pieces and send the pieces to your destination, who then reassembles. In IPv6, this does not occur. If the packet must be chopped into pieces, then that chopping has to be done by the sender. And the sender is made aware of this using various control message protocols, and it has to estimate what size packet it is able to send. This does not work well. And so UDP for IP version 6 is less reliable in the current internet than UDP for IP version 4, because IP version 4 has got extra features and it has got a certain flexibility in this regard. So we believe that we're going to find some responses that are not able to reach some people in an IPv6 only environment, and that they will end up retrying with different options, maybe a smaller buffer size, maybe they'll retry with TCP, and we're going to be able to see that behavior in our network trace data and make that data available to interested researchers, because I think we're going to discover that certain things about IPv6 are not going to work in UDP unless we make further changes to IP version 6 itself.
Okay, 其实紧接着这个问题，其实我还想问一个，因为我做 V6挺长时间了，就是如果在纯 V6环境下，是不是会引起 DNS 协议的变化？比如说用 TCP， 比如说用 HTTP， 或者更多交互来携带更多的信息、更大的数据包。这样的话，是不是能引发这个跟服务器在体系结构上可能的变化？
Okay, I'm sorry I did not hear the translated question.
My question is that given the background of IPv6 only environment, we should introduce more features or changes to the DNS protocol. Maybe we use TCP or HTTP or multiple response to got more large packets and more information from the root server, from the DNS server. So is that true? Is that possible that IPv6 only environment will change the architecture fundamentally?
Unfortunately, it's hard to do good science in that question. The reason it's hard is because IPv6 nodes are new. All I mean by new is that if you're speaking IP version 6, that means that your operating system has been updated at least once in the last 10 years. And I realize that that seems like it ought to be very common, but it's not. Quite a bit of the internet has not had its operating system updated in 15 or 20 years. And at the moment we still have to serve those older nodes. In fact, I think we'll always have to have some small IP version 4 legacy network for those older nodes because they might be industrial control systems or other types of devices that can't be upgraded. But in any case, what that means is that as we do our experiments, we're going to be talking to only new hosts. And so that means they will have certain powers that are new. They'll have other upgrades, not just IPv6. They'll have more memory, they'll have faster CPUs, they'll have more modern operating system kernels, and so forth. And so there are certain defects that I would like to be able to detect that we can't because we made the decision early on to run an IPv6 only network, which creates necessary, unavoidable, but nevertheless regrettable selection bias. We will not be trying to find out what happens with older hosts. So unfortunately, we're not going to be able to answer the question that you just posed.
Okay, thank you for your answer. 还有问题吗 Andrew, I saw you from, and maybe you will come up with some questions. I will give you mine.
Right, thank you. Hi, Paul, it's Andrew Sullivan here.
Hello, Andrew.
So, I understand, obviously, why
I'm sorry, you're breaking up. I don't hear anything now.
Okay, is this better? No, apparently not.
All right, try now.
All right, I understand why the decision, why you made the decision to mirror the IANA route faithfully. That makes a lot of sense. But many of the questions, many of the controversies around the root name server are not actually about the root itself, but in fact about the names underneath and the kinds of things that you can do. So is there any intention to use the studies you get from this to inform, ways of studying what you would do with the root zone itself?
Well, so yes, but only indirectly. So let me explain. All of the trace data we collect will be made available to interested researchers. In other words, anyone who wants to do science can propose an experiment, and anyone else who wants to do research can see all of the data that we collect. and we expect that a number of those independent scientists and researchers are going to have certain questions they wish to answer, and they will write position papers, they will write maybe some polemics, they will argue that a certain thing should be done or should not be done by the IANA system based on results that they obtained by using our data or by using our system to conduct experiments. We think that's a good thing. Now, as to your specific question, I am, among other things, a scientist, and I am looking very closely at this experiment because I want to see if I could propose to IANA that they themselves might produce more than one root zone that would all be signed with the same key but would have different sets of top-level name server names. And it may be that they would produce a mirror copy of their root zone that offered let's say, a name server set that was unique to a certain country or unique to a certain Anycast cloud or something like that. And if we can prove that multiple zones all copying the same data and the same metadata about TLDs can allow the IANA namespace to be used independently and autonomously, then I believe that I am at least, if I can make that case, and if I can make it objectively using repeatable, transparent science, I'm going to be arguing that IANA ought to do this in order to make certain features available, maybe new protocol features that only new DNS servers would speak. For example, if we wanted a TCP-heavy network where the only servers that we're going to be running would be known to be able to support tens of thousands of concurrent sessions. That's something that would require this as one of its foundation stones. So I think the answer to your question is yes, indirectly, because for two reasons. First, that we're going to permit all kinds of people to do their own independent research using this data. And second, because I myself have an axe to grind, and I'm planning on trying to grind that axe using this data.
Okay. Any questions?
Okay, my name is Ma Yan. I'll be in Chinese. 技术上面听到了，还是有挺多特点。但是我的问题是说，从技术角度讲，如果他自己定义了copy 这个 root data、root server data into locally， 再靠到本地来，那如果本地做了任何变化以后，怎么样能够返回到全球的这个 root server system 去
Okay. I will help to translate. Technically speaking, okay, we can see you. Okay, Professor Ma just asked a question that if we change the local, you mean we just download the root zone from the IANA, right? If any changes happen suddenly, is there any possible that can update to the IANA zone? Yeah, that just like that. Is that any possible technical way to centralize the two, not just downside?
因为我们需要做互联网，一个
yes,
域名。
yeah. Given that we need one world, one internet, and one namespace, if there's any changes locally, yeah, people may afraid that any data changes by local users, add a new GTLD or such things may happen. Is that possible to update the changes to the IANA, or we should guarantee that we have the one IANA namespace, just follow exactly for the IANA?
So, there was an audio problem during your question. I heard a lot of echo. I think you're asking if it's possible that we may someday become a source of updates for the IANA system. In other words, if the data could flow from us toward IANA rather than flowing always from IANA toward us? And I think the answer is no.
回答是否定的，就是说我们要一直保持跟 IANA 数据的同步，因为它那边是就是会汇聚所有的这个名字。
我再问一下，是不是的确只能是one direction, not bidirectional?
Okay. The question followed is that it's only possible for one direction data flow, right? Download, right?
Yes, but I want to answer a different question because it may be that a different question was intended. In the ITI panel, the Innovations and Technology in Identifiers panel that was chaired by Dr. Paul Markopetris as part of the ICANN work last year. And I was a member of this panel. The final report indicated that one of the things that panel believed should be done is to come up with a voting system of some kind so that the namespace could be managed by cooperating partners rather than being managed by a single functional contract such as IANA itself. And this was seen as possibly allowing a different way of doing internet governance, because right now, since there is only one IANA, then a lot of people, governments and companies around the world all want to argue about, well, who is in charge of IANA? And so the idea here was if we had a namespace that was somehow able to accept updates from multiple cooperating parties, could that change the calculus of internet governance? I think it's an interesting question. And I think that later, not in the first year, but eventually, we might encourage independently funded researchers to come up with some protocols that we could speak through the distribution masters of the Yeti system, so that a change could come from any of the different distribution masters and would then flow toward the others, or perhaps a voting system where 2 of the 3 had to agree or something like that. So that we might do some research in the area of multiple masters, but that would depend on some outside party who thought that was important, who would then contribute the resources to develop the protocols, develop the software, and propose the experiments and so forth. So I would like to see Yeti used for that, but even in that case, no data from the Yeti system would ever flow toward the IANA system. Only scientific results would flow.
Okay. Just based on your discussion, I just come up with a new question, maybe to Paul, David, and Andrew at the same time. Maybe people were afraid that anyone can download the IANA's room and hold their local root. It will be misleading that any home, ISP, enterprise, or country could possibly technically break away from IANA and start their own internet. It's a disaster for internet guys, you know. So is that any possibilities to accommodate to fit the 2 needs? One is localized service, one is follow the IANA technically strictly. Yes. Did I make my clear?
You're very clear. I think you've asked an important question. I know we're over time, so thank you for letting me run long. So the answer is yes. The observations I've shared today and the Yeti system are both proof that some company, some ISP, some country could break away from the rest of the internet and decide that they wanted to start their own. So that part of what you said is true, but there are some implications that I think follow or in one case don't follow. And so the first implication is that this would actually work. And you have to realize that because of VPNs, it is not possible to require cooperation in one of these. I'm referring to them as a circle of cooperation or as an autonomous network. Even if you make it the law of the land, there will be some people who will use a VPN to reach the IANA servers and to see only the data that is in the IANA system. And so, regardless of the intent of the autonomous network, there will always be visitor devices that have their own programming and have their own policy and don't wish to participate in that local experiment. And so they will see different names in the example you gave. So in the example of some company or ISP or country who wants to start their own namespace, that will be unreliable. And so it might be that this could be done in order to, I don't know, make a political point, in order to demonstrate something for the purpose of some larger negotiation. But I don't think that it would be effective. And I think the fact that it is not effective is what will cause people to not try to do it.
David?
So back in 2010, when we were in the process of signing the root, I had actually made a proposal that appears to be actually identical to the Yeti DNS. Yes. And it's in the context of signing the root, and we were working with NPA and Verisign in that process. That proposal was shot down in flames because a number of folks, NTIA, some of the root server operators, were concerned that it would set a precedent for creating an alternative root. And at this point in time, this is before the root had been signed, the argument that the namespace and the implementation of that namespace are two different things, and it's entirely feasible to have a different implementation of the same namespace, didn't really carry a lot of weight because people were just terrified of fracturing the namespace. Now with DNSSEC, I actually think...
Speak louder.
Oh, I'm sorry.
Translator cannot hear you.
Yeah, sorry. Is this better?
Much better.
Okay. Now with DNSSEC, I actually think another concept comes into play, and that's what's called the tyranny of the default. For someone to change to point to the Yeti DNS, they actually have to change the pointers to the root servers, and they have to change the trust anchor. And the vast majority of people will not do that. They will go with whatever their operating system ships with. And this will tend to lead to if the namespaces differ, this will lead to an unreliability factor that I think Paul mentioned. So I think now with the root being signed and enough time has passed that many people who were very much against this idea may have become more moderate, gotten older, more relaxed. It's possible that this won't generate as much flame as a previous attempt at doing this.
Thank you for your sharing. Okay, is that possible that, technically speaking, is that possible that the IANA only sign the TLD and the CCTLD records, that just let the Apex or NS records alone? Don't sign the NS record. Is that possible? So they guarantee the encode, right? The trust encode.
So
at the same time, but it can't use on the local.
Is it technically possible?
Mm-hmm.
Yes. Is it practically possible?
Mm-hmm.
My expectation would be, not in
看这个环节提问还比较充分了哈，大家还有什么更多的问题？你可以直接在那个。
我想问一下啊，就是说我们现在很多的恶意行为，包括钓鱼啊，包括僵尸，他们都会使用域名。那么我们会在跟服务器上做哪些工作，或者在哪些方向展开一些研究，来对用户做最终的保护？因为我们一些恶意域名，它最终解析都需要用到跟服务器。那么我们在这方面有哪些好的研究方向，会有什么方法来进行一些检测，从而能对用户进行最终的保护？
This question is simple that now the DNS system now be a security vector, right? Does attack, malicious mail attack. Is that the root system can be a role, play an active role to help to protect maybe the end users or enterprise users in a positive way. Oh. Ready?
So the answer is yes. When I mentioned the external dependencies, I was thinking about DDoS attacks, and I'm thinking of two things. The first is that FRoot was the first root name server that made a lot of copies of itself. And the reason that I did so is that for a brief glorious time, David Conrad and I both worked at ISC at the same time. And he said the only way we can solve the DDoS problem is with really, really wide-scale anycast. And then he left. And after he left, I said he was right. And so we started doing that. And a lot of people started to say that this was somehow the motivation that someone might have for helping ISC to run a root name server is that will speed up their internet because they'll have a local server to talk to. And when I was looking for good reasons why people should run these servers, but I knew that was a bad reason, and so I always disagreed, because if we're not going to make your internet faster by sticking an anycast node next to it, you would have to have all of the nodes close, because your recursive server is going to periodically try and reach all of the others to see if any of them has gotten any closer, or to see if the one you've been using has gotten any further. It's sort of an adaptive mobile algorithm, and that means that a lot of your packets are still going to be sent to the rest of the world, even if you have a name server close. But what you will have is DDoS protection, because there are now, I think, 54 copies of FRoot all around the world, and it's very difficult for an attacker to target all 54 of them. And the attacker will tend to target the anycast address, and so their attack will end up going to only the region that is close to their attacking nodes, and the rest of them will continue to serve normally. And so I don't think that anycast has made the root name server system any faster, and I think that David Conrad's slide about latency for different countries and different ISP shows that. But what I do think is that if you have more servers, then you have more targets, and it is very difficult for an attacker to target many different victims at the same time. And that principle applies here. I believe that to the extent that all of us have an external dependency on root name servers that are outside of our network, that we can manage the risk of that external dependency by building our own autonomous root name server system inside our own perimeter. Because no matter what happens with DDoS to the IANN root name server system, your internal root name server system will be unaffected. And I think that is one of the two great benefits. That and surveillance are the two great risks that can be mitigated in this way. So thank you for that question.
Yeah, one aspect is a DOS attack to the server, DNS server. I think that this gentleman really want to exploring the possibility that the root server or the just high-level architecture system, internet highly architecture system can protect the end users. For example, escape from the phishing attack or such domain-related attack. That's the end user's perspective. I just gave a mail to him. Okay. Do you want to?
Yeah. This is David Conrad again. So, yeah, closer. Okay, how's this? Technically, it theoretically would be possible to insert records in a root server that would be able to respond to any query to disable, for example, a phishing domain or something like that. And that will remain true as long as an enhancement to the DNS called query minimization is not implemented. And there is some interest in getting query minimization implemented. But pragmatically speaking, the mechanism by which you would do that would require a quite significant change to the policies associated with generating the root namespace. Right now, the root namespace is only allowed to contain top-level domains and NS records for those domains and DNS-related information. Anything else would require significant change in policy. So while it is true that it could potentially be done, at least until query minimization is implemented in most resolvers, pragmatically, the policy implications would be such that it's unlikely to happen again in my lifetime at least.
OK，我简单给一个回答，就是他的David 就给我们一个提示，就是说在访问顶级域的时候，容易泄露一些你查询的信息。现在有 IETF 有一个工作组在做一个标准，就是说在你访问的这个链条上，不把所有的信息都去访问。比如说访问根，它只会给根的根的这个查询，它不会访问百度点跟或者淘宝点 com 或点，它就会缩小这个查询的这个信息，从而达到保护用户隐私的目的。我觉得这个可能是对这个 end user 终端用户有这个 benefit 的地方。好，我们在这一环节花了不少的时间，那可能这个茶歇我们要稍后往后延到开放论坛之前了。那有请下一位演讲者是 OK Paul. We'll turn to another speaker now. Good night. Thank you for your all the time sharing with us. Bye. OK， 下一位演讲嘉宾。
Thank you so much, and good night.
Good night. OK，下一位演讲嘉宾是 Andrew Sullivan， 也是我的一位个人的好朋友他来过我们工程中心有过交流，然后给我们这个相关的这个工作提过很多建议，也是我工程中心和域名工程中心两家工程中心的这个资深顾问了。好，让我们有请 Andrew Sullivan 来进行他的 topic， 欢迎。
Thank you. I will, is this on? Yes? Is that better?
Oh, you need to turn on that track. Sorry.
Is that better? Yeah, there we go. I
knew I couldn't hear myself booming. So thank you very much. When Davey invited me, you'll notice that I took the tie off from this morning because he said it will be more informal in the afternoon, more like the IETF, where I spend more time. So I thought that rather than preparing a lot of formal remarks, I would talk a little bit about some of these topics that you see here, and we would be able to have a discussion. So if there is anything that I say or that you disagree with, or you wonder about, or you have comments, feel free at any time to interrupt me. This is very easy for me to talk about, and I don't have a lot of structured remarks, so the mic is open anytime. I should say a little bit about my roles here, because of course I have my day job with my employer DYN, and I am also the chair of the IAB. As I suggested earlier, the IAB told me to come here and listen, and I've been listening very intently and enjoying our discussions so far, and I will enjoy them again tomorrow. And I will report back to the IAB about things that I learned here. I will sometimes note IAB positions as we go along, when they have been formally adopted, like when there are RFCs for them. But you should understand that when I'm speaking, I'm really speaking for myself. I am a fellow at DYN, and this company, DYN, D-Y-N, it is spelled, but it's pronounced DYN. I'm going to talk about my work there and things that are relevant to our things. Now, one of the topics for this meeting has to do with the future network. And there is this proverb that has floated around, many people are reported to have said it, that predictions are very difficult, especially about the future. The thing is that when we make predictions, of course, we're assuming something about how the world is going to be, and I wish that I had a crystal ball and could say with certainty how the network will develop, because I would go out and buy shares in those companies or something like that and become very rich. But alas, I don't know any more than any of you about what the future is going to look like. So, you know, my predictions are not always that great. Nevertheless, so I want to make a distinction that is important and that we sometimes do not pay enough attention to. And that is the difference between names and identifiers. Because humans use names. And we use names all the time. An important feature of names is that humans are context beings. That is, we pay attention to the things that are going on around what we're talking about. And so when I talk about, you know, my boss, and I refer to Matt, Matt is my boss's name, it's the same guy. And I know it's the same guy. But if I'm in a different context, like for instance, I'm on an IAB meeting, we have a different Matt. And so if I say Matt in that context, it doesn't mean my boss. And my colleagues on the IAB would not expect that Matt to be my boss. And I sometimes make a mistake and then I confuse people. This is okay with humans because of the way we talk, right? I'm looking out at you when I'm talking, and I'm watching for people nodding or falling asleep, because maybe maybe I'm not making myself clear. And so what I have to do is look for clues, signs, feedback. Well, it turns out that computers are not that good at this, right? If you want a feedback loop for your computer, you have to set it up. You have to set it up explicitly, and you have to train it in how to interpret that feedback loop. Instead, what computers like are identifiers. Unambiguous things, they need not be human usable, right? Computers don't have memory limitations. They can remember XP6493321X just as well as they can remember Andrew, whereas I can't even remember what I just said. I can only remember Andrew because it has a semantics for me. The computer doesn't care about the semantics. It does mean that the computer needs the identifier to be unique. It can have a context, but the context has to be explicit. So it can be, for instance, that you can have a thing that is only unique within a given context. For instance, RFC 1918 addresses are unique, but only within the local network, right? If you take 10.1.2.3 and carry it to another network, you're out of luck. Whereas if you carry most standard IP addresses to another network, it still is the same identifier. Of course, these kinds of identifiers don't need to be any kind of language at all. That's another thing about humans. We use the names as linguistic components. So a really important part of this for computers is because they don't have this contextual trick that humans have, you need to have a strong and clear relationship between redundancy of information. That is, if I say Matt and my boss, for me, this is very easy to understand that redundancy. They're just synonyms, right? But for the computer, it's not there. And it's better, in the case of the computer, to make a pointer, right? You make a pointer, everything points to the one final thing, and then everything else is a lead to it. And the very best thing you can do is to have two-way pointers, so you can find your way from one to the other no matter where you come in. That's usually the best way. All right, why am I blathering on about this? What does this have to do with the future? Well, it turns out that in architecture, I'm supposed to be an architect, right? So in architecture, you're supposed to know what you're building before you start to build it. That's not how everybody builds things, right? I'm sure you've all worked on computer programs that have been built by somebody who clearly did not know what they were supposed to be building before they built it. But when you're designing something, you should know what it is you're trying to build. And it turns out that the naming system that we have on the internet, the thing we use as the source for names, is problematic as a naming system. It's not a very good naming system because it's not that great for humans. It has arbitrary restrictions that are not like language at all. The semantics of the identifiers are poor. And yet, so really, right, this is an identifier system. It's a pretty good identifier system. But it's leaked. It's leaked up into these environments where humans see them. So humans are grasping these identifiers and they're using them as names. And humans are messy things. They want what they want. And so they start to use these names, these identifiers, in name context, and they want the ambiguity that comes with their language. They want the richness of the semantics built in. Now, all of this is important because we've got certain kinds of successes that are important on the internet. And you might be wondering at this point, by the way, you might be wondering, what does this have to do with the future? We already know all of this. But I'm telling you, I'm setting this up because we're going to build something. We're going to build this Internet of Things. They're coming. And so the question is, what are we going to use in building this? And I think that the DNS is part of this story. So the question is, why do I think that? The reason I think that is because of this RFC 5218. When I joined the IAB 2 years ago, I had read this and I thought, oh, this is a pretty good document. But I didn't really fully understand how rich it is, actually. Because what it does is it observes this set of patterns about how protocols are successful on the internet not in individual networks. Individual networks, lots of things can be successful because you have a purpose for that network. But on the internet, when you want to expand in this enormous way and you want to have things that just come along and you pick them up and you plug them in and they work with everything else, in that environment, the question of what makes a successful protocol is a really important one. And the reason it's important is because you don't want to ship, 100 million of a product and discover that your protocol doesn't work or that nobody else is going to do it. Because what will happen is you'll have, 100 million boxes in a warehouse and nobody will buy them. Not so good. So it turns out that there are some things that we can identify about protocols that make them successful. And the first one, no big surprise here, is that it meets a real need. It must actually do something. But the very next one is incremental deployability. And by incremental deployability, we say there are a couple of parts of this. The first is that a bunch of people can deploy it and it doesn't require everybody else to do it at the same time. But the second part of incremental deployability is that people get value out of it at the beginning. So the second part is not actually absolutely necessary. You can have an incrementally deployable thing. It doesn't require everybody to upgrade on the same day, but nobody gets any value until most people have deployed. That's not a very popular one. That's what's wrong with IPv6, for instance, right? IPv6, if I deploy IPv6 and nobody else does, well, it cost me some money and nobody else is talking to me on IPv6. So a lot of people have to deploy IPv6 in order for IPv6 to start to get a network effect that makes it valuable. But it's still incrementally deployable because I don't have to turn off IPv4. This isn't like when we first turned on IP. Way back in 1983, I think it was, there was a so-called flag day where everybody on the internet had to switch from one protocol to another. Didn't work very well. And so that's the kind of completely not incrementally deployable. That doesn't work at all. The very next thing for success is open code availability. So if there's just a protocol and then you have to write your own code, that protocol doesn't take off. Freedom from use restrictions is a close partner with this. You need to have something that is easily used and so on. And then we get down here to the bottom of this list, and there's a couple more there, but you can read the RFC if you really want. I want to point out, though, that the very last one in the list is good design. Good technical design loses all the time. Nobody cares about good design if the thing is freely available and you can deploy it easily. It can be garbage. Now there's this idea of wildly successful protocols, and I won't go into this too much, but wildly successful protocols are ones that are massively successful beyond their wildest dreams. The most obvious example of this is HTTP, right? Now everything is using HTTP. Nobody uses any new Telnet, that's dead. All this other stuff. No, we don't use any of that. We just put it over HTTP. So it's a wildly successful one. And why? Well, because it meets a number of these criteria. In particular, it's extensible. You can just keep adding things to it. It doesn't have a hard scalability bound because of the way it's designed. The first version actually did have one, and it's been fixed over time. And then there's this weasel word here. The threats are sufficiently mitigated. And what that means is that the attacks against this system can be dampened enough for the kind of level that you want to deploy it at. So it doesn't mean that all of the threats are not there. It means that if there is a threat, then you can solve it well enough for your purposes. Which means that, the mitigation can be pretty bad, and it's still good enough because you can get your traffic through and so on. So this is wild success. Okay, so what does this have to do with the future internet anyway? Sorry, all of that blather just to get to the topic. Well, What I have been observing with the Internet of Things so far is something that I am seeing over and over again on the internet, and it's really starting to bother me. And that is, there's been this enormous turn back towards a kind of development that we got rid of way back in the 1980s, maybe late 80s, maybe 1990s. And it was this so-called walled garden or closed system approach. The idea is that you've got a single ecosystem and you talk to that vendor or that system, and all of the services are between you and that thing up there. It's a sort of bilateral system, and everything is bilateral, right? So if you've got a new device over here, it's got a new bilateral relationship. And you buy an internet-enabled, I don't know, bathroom scale, and it talks to the bathroom scale manufacturer. Did you know this? There are bathroom scales that talk to the internet. I don't know. I don't really want people to know how much weight I've gained myself, but that's what is happening, that every one of these is a sort of two-way street. And this is a thing that the internet completely triumphed over, in its great march towards popularity throughout the 1990s. When I started because I started not in computer science, and in the humanities we were locked out of the scientific networks. We couldn't get in because what do we want those stupid humanities people talking to our internet for? So I had to use crummy online services. These went under names like CompuServe and Genie, and there were a whole bunch of them. And they were all pretty useful, but if you wanted to talk to somebody on a different network, you had to go and sign up to that one. And when I got access to the internet, then I could throw all of those subscriptions away and just talk to the internet, and I could talk to all of my friends everywhere on the internet, and it was great. And what's happening is, in the Internet of Things today, what we see is an attempt not to allow you to talk to all of your friends, but instead, you buy this device and you talk to me. You buy that other device and you talk to me. It's always this bilateral system. Now, for myself, my question is, why would I want to buy such a thing? I don't want to buy those kinds of things. I want my Internet of Things where my Internet of Things can talk to one another, because I get more value out of my things when they can talk to each other. When my thermostat can talk to my light switch, can talk to my furnace, can talk to the home automation system, that's a good thing for me, because then I can manage my house. When my fitness, when my lack of fitness things can all talk to each other, then I can get some benefit out of that. And I don't want to have to buy all of this from one company, because not every company is great at making every single thing. My old-fashioned thermostat doesn't come from the same people as my light switches, because I want an electrical company to do my light switches, and I want a heating company to do my thermostat, because thermostats have to do with keeping me warm, and light switches have to do with keeping me bright. Well, this is really a basic problem, because the incentives for the vendor, or the incentives to the vendors are lined up the other way, right? They want to make sure that you're buying only from them, and they got you in this complete silo. And we see a bunch of problems with this, and some of them are costs to the manufacturers themselves. These costs are that they're reinventing things that we've gone through painful lessons to learn. So they're slow, I don't know if you have this in Chinese, but there's an expression in English, reinventing the wheel. And one of the things about reinventing the wheel is often your wheel is square. So it doesn't work very well, and you have to learn over time, I have to make it round and put an axle, all those things. You're going through all of this work that was done, thousands of years ago, and that is happening with a lot of the products. We're seeing that frequently. The problem for the consumer is that the consumer can't put things together in arbitrary ways. So one of the things that I have found really nice about the internet, and in fact one of the things that we have seen is an engine of innovation on the internet, is the way you can just glue things together in surprising ways. You take, a thing from over here and a thing from over there, and you say, hey, I could put these together in this new way, and suddenly you've got a new product that nobody thought of before. That's a nice thing, and if the control is all in the manufacturer, then you lose that ability. You have to be a pretty good mechanic to do this with your car. Right? You can't just take a thing from an Audi and put it in a Mercedes and it'll just work. That they in fact set it up so that you can't do that. And the history of mechanical engineering, of course, has been an increasing standardization. Right? So we have standardized bolts and standardized metrics and standardized tensions and so on. And then you have specifications built on top of that. And we're going the other direction. Another couple of things, of course, is that if it's all controlled by the vendor, then the vendor knows more about you than you yourself do. You're sending all of this data to the vendor, you don't have control. But much worse, actually, is that vendors go out of business or abandon product lines. And now this thing that you spend, sometimes a lot of money on because some of these devices are expensive, it's suddenly a piece of toxic waste, right? It's got batteries, and it's got lead, and it's got plastic, and it's got cesium, and all kinds of stuff in there, and you have to throw it away. So that's a really serious problem with these things. So, I started this thing with the DNS, and I asked myself, is the DNS a good identifier system for the Internet of Things? I've just argued that the identifier system that we want is not one that is being manufactured by the vendors of these devices, because they're going to make us something that is under their control. And I want something that is ubiquitous and that's easy to do. Well, if I look at the DNS, it has been ubiquitous for many years. It's everywhere. Every device you have, right, I've got, 5 of them on me. And they all talk the DNS, because without the DNS, you can't get started. We can presume, I say, a real need for some kind of identifier system. And we can say that the code is certainly available. There's lots of DNS code that's freely available. But the DNS, it's not an obvious fit here. It doesn't look great. But remember that earlier thing I said about wild success, or even successful protocols. That it's a good technical design is really low on the criteria for being useful for this. It's rather that you can pick it up and use it and do something fast. I think that this is a key piece of insight about the way internet architecture works. So I'm going to suggest that what will happen is that for the Internet of Things, we will see DNS becoming an important part of the control infrastructure for these things. Not that humans are using DNS names, right? I'm not going to configure thermostat.andrew.house.livingroom. No, I'm not going to do that. No human's going to do that. It's going to be in an app, and I'm going to click buttons and so on. But it's not useful for designers of those applications to know all of the information about what IP address it is, to have to do the discovery all of the time and so on. It's just cheaper and easier to look it up in a widely accessible database. And in that sense, the DNS can easily become a piece of control plane infrastructure for all of these kinds of devices. It means re-embracing an old-fashioned picture of the way the DNS worked, which was not, this thin layer near the root and a name underneath it, but instead a deep hierarchy, and hierarchical names with lots of automated management of these systems underneath. The reverse tree, PTR records, inadder.arpa and friends, they become valuable parts of this infrastructure so that you can manage these systems. It seems to me that this is the reason we've got a bunch of older technologies that are poor fits for what we want. This is, I suggest, the reason that the DNS is still used as a naming system. It's a lousy name system, but it's the one that's already deployed. And so we're going to continue to use it because it's already there, and it's hard to get rid of something that's already deployed. Because remember that first thing, you need to satisfy a real need. Well, my need is satisfied close enough. I'm not going to upgrade the whole internet in order to fix that. It's good enough. It seems to me that once the technology is abused for a purpose or just used for it, it's going to continue that way. And there isn't that much investment that's necessary in order to recycle these kinds of protocols. And I think these are key pieces of the way any future internet infrastructure is going to be developed. Look for old protocols. Look for protocols that are already widely deployed and look for new uses of them. Because that is how things get deployed on the internet. You pick up the thing that's already there and you add some stuff to it. I'm going to whack this microphone again. That's why HTTP continues to be used the way it is. And it's the reason that the DNS continues to be used the way it is. It's the reason that multicast DNS reuses the same packet format as DNS, even though it's on another port, and DNS was nowhere near what they wanted. It wasn't what they wanted, but it was good enough and close enough, and the libraries were there and free and easy to use. This recycling has two properties. It reduces the cost of the person who's deploying it, and the other thing is, if there are costs, it pushes them on to other people. And this is, to me, an important part of the nature of internet architecture in general. That isn't to say it's pretty. It hurts my heart to admit this about the internet architecture, because it means it's ugly. But it also means that it works. So it doesn't offend my engineering principles in that sense. The thing is that the DNS is an excellent identifier infrastructure, and I believe it will be used for the Internet of Things. It's a terrible naming structure, but we don't care. So we get a sound but ugly architecture. We add overlays atop existing deployed infrastructure. And this is, I think, one of the insights. We started the day talking about SDN, and the other workshop session is working on SDN. And this is one of the key things that SDN embraces, right? It just more overlays. Oh, I want to put I'll put another overlay on top. That's okay. I mean, I look at it in one sense and I think, this is awful. Why would you do this? This is more complex, but it's not more complex down in the code. Down in the code, you just reuse the same thing you already did, put another thing on top, and so you make it, you make it ugly down in the guts, but nobody ever sees the guts. What they see is this nice interface up above. That's why I'm standing here rather than my insides. So there's this basic idea that what we're trying to do is serve interoperation, and that's the most fundamental goal. If interoperation is your most fundamental goal, then maximizing reuse of things that are already deployed turns from like, oh, I've got this ugly hack I got to drag around for 1,000,000 years, it turns it into, I've already got deployed code, I can turn this on tomorrow. It makes something that feels like a disadvantage into a virtue. So those were the remarks that I had to make about how the DNS and its relationship to the Internet of Things can illustrate these issues about architecture in general on the Internet. I hope this has been useful or entertaining or something. And I'm happy to talk or have questions or whatever you like. But I'm also aware that we skipped the tea break, and so it may be that you're all just thinking, I want to go to tea. Thank you.
看有没有问题，关于命名服务器，关于 IoT 的一些。
Hi, it's Richard from BI. Sorry that you may got the feedback later. So I want to ask some ethics on my own observations in the IETF task. So I think now we are facing a dilemma on the mailbox. So the problem is that if you want to do some really new things on a new draft, the middlebox wouldn't support it. But if you want to do the thing that the middlebox totally supported, there's nothing to do. So I wonder, it's my own hope. Could we have made a consensus that some of the protocol we should assume that they are supported by all the middlebox, so that we can push the middlebox to maybe be accurate. For example, the EDN0. Every new fix on EDN0 faces a problem that there are, I don't know what the really percentage, I think it's somewhere around 20%. Middlebox that are not supported for EDN0, but EDN0 is actually a really old protocol and should be supported, I think. So could we do something that we just think they are supported and we force them to upgrade the middlebox that we can move on. Thank you.
中文。
我翻译一下，就是我现在觉得就是在 IETF 里面，我们现在面临一个两难的境地，就是说，关于这个中间设备，它对很多协议它不支持。那么如果我们要做一些新的创新的话，你就会遇到一个问题，就是很多中间设备它不支持你的新协议。如果你去做一个协议，它完全所有设备都支持的话，你会发现你基本上已经没有什么东西可以做了。那么我就想知道，我们现在能不能在IETF 上达成一个像 RFC 一样的共识，就是说我们能够确定一些那个技术，我们虽然说它确实还并不是被所有设备所支持，但是我们认为它已经支持了，这样我们能够去提供一些强制力，让一些设备商去更换它的设备，去升级它的设备。比如说 EDN0这个协议，所有在它上面的创新都会遇到一个问题，就是20%多吧，我记不清楚到底20%多少的设备它是不支持 EDN0的。那么，但是 EDN0已经出了，反正是比我接触互联网时间久了，所以我觉得我们能不能去做这样的尝试，去让这个中间设备商去更换自己的设备，或者是升级自己的设备？因为如果我们不做这样尝试，那么中间设备商他认为所有的你的所有的新协议都会根据他现在有的老的设备，他当然就没有必要去换新的设备了。谢谢。
One of the things about middle box discussions is that there is sometimes a desire to have a perfect solution for all cases. And in particular, when you are looking at new deployments of the sort that, for instance, Internet of Things kinds of deployments represent, or so on, maybe the answer in those cases is, yeah, we don't care. It could be that sometimes the answer for some of these sorts of issues is, if you have a crummy box that doesn't support something that is 10 years old, then we're just going to let you go. An example of this actually is MDNS itself, the Bonjour protocol that is used, for service discovery and so on. Apple started it, but it's used on lots of systems. You know that in the DNS there is this traditional restriction, letters, digits, and hyphens, the ASCII letters A to Z, the numbers 0 through 9, and the hyphen character, and nothing else. That is a convention and not a limitation of the protocol. When MDNS was specified, one of the things they said was, well, we don't care. What they're doing over there doesn't matter for our deployment because we're not going to care at all. Now I picked this answer, this case, because it's a cautionary tale. On the one hand, that worked fine, and it's true that you can use even spaces in a name, in a DNS name, that is in use for Apple's Bonjour. So wide area Bonjour happens across the internet, and it uses regular domain names, and you can put spaces and apostrophes and Chinese characters in UTF-8, not in XN ---- nonsense. All of those things are fine. The only problem is, if you want that thing to interoperate with other domain names that are using the IDNA protocol, that is, the one that uses Punycode and does the conversion and so on, then they don't work together because the one wants to use UTF-8 and the other one wants to use IDNA, and these are at cross purposes. So now we have to come up with like another overlay that glues them together in some ways. And this is one of the disadvantages with the approach that I'm talking about here. I still believe that the approach that I'm talking about is in fact the architecture of or an important part of the architecture of the internet. But it is a frustrating part because you're right, then you have to drag along all these middle boxes that are so bad. One thing that I think could be useful is when industry consortia and groups that are working on new protocols and so on are getting together, if they specified the features that they need, then you could in fact define a test suite that covers relevant things out there and release that as free code. Right? This is the key thing. The code availability was, I think, number 3 in that successful protocol. So you release something that can tell people, oh, I want to use this device. Does my internet, does my home router solve this, for instance? And you have to go to a website and press the button and see if it works. And then this thing has to do some testing all the way back through your network to do some things. And maybe it would discover, no, it doesn't. It's your device now. It's the device in your network, so you have to fix your network. If we could provide consumers, and this is going to be super important in cases like the Internet of Things, in wearable things, and all the rest of it, because this is a consumer device environment we're talking about. This is not the 1990s, right? I used to go out and I would fool with my computer for hours and hours and hours to make it work. Nobody is going to do that. They go to the store, they buy the thing, they take it out of the shiny package and they plug it in. That's how much work. So you've got to have this plan. And for those of us in the internet protocol business, this is a weird thing to have to think about, right? You never think about, well, what is the usability consequences of this protocol decision? What does that even mean? User interface. We don't do user interface at the IETF. Well, we're going to have to. We don't have any choice. Because if we don't think about those things, we're going to make things that are undeployable. The real proof of that is the success of Skype. We have Skype and we have SIP. And SIP is the full-bodied IETF-defined protocol for how all of this stuff works. And nobody ever asks me, can I make a SIP call to you? They say, I'm going to call you on Skype. Why? Because there are 3 million ways of the NAT breaking SIP. And there are no ways of the NAT breaking Skype. They have figured out how to get around everything. Their protocol is ugly, but it works.
Andrew, thank you, Mark, from DNS. Thank you for your speech, which, by the way, is very instrumental to me. My question is about DNS. Dan, as we all know, within ICANN, there is a DNE working group which is intended to use DNS as a language BPI to authenticate names in internet. But the security of DNS itself has been changed. So do you think we are all well prepared to do that? What's your opinion?
Well,
okay, let me add something. For example, the working group tried to use DYN to publicate public IP state exchange material and TLS material and even some CS information. So we think we rely heavily on the DYN to reach security design goals.
So I think you're right that there is a worry, but I think that this is an example of trade-offs. And so there are three things that I would say. The first thing is that the system that DYN is aiming at, is aiming to augment or replace, depending on how you feel about these things, is itself a little fragile. Right? So the X509 CA system that we have turns out to be, on a good day, somewhat vulnerable to attacks, and on a bad day, like cheesecloth. It really depends very much on the CAs themselves. Now, the people who are certifying those certificate authorities, who are including those certificate authorities now, have awakened to this, and they've started to worry about it. But people that I talk to who are involved in some of those things, many of them are entirely sad about the state of affairs. They don't believe that it will get any better, because they believe that the incentives to undermine a certificate authority are really great, and the incentives for the certificate authority to get better are not there. So that's a really big problem with that thing. Nevertheless, you're quite correct that the entire DYN strategy absolutely depends on the ubiquity of DNSSEC. And if we don't have DNSSEC everywhere, and if we can't rely on DNSSEC, or if DNSSEC itself can be compromised, then the entire strategy falls apart. And this is a brittleness in that strategy that is not very attractive, because what we would like is something that is really robust against all of those kinds of attacks. However, there is something else to be said about DNSSEC, and that is that DNSSEC plus DYN, and that is that it moves the requirement to look after these issues and to pay attention to key sizes and control of those things and exactly whom you're going to allow to sign and so on. It moves it away from somebody else's hands, the certificate authority, and it moves it into the hands of the operator who is doing the work. And that final bit is, to me, one of the things that is most attractive about it. Because what it does is it moves the costs and the benefits down to the same people. And so the people who are making the trade-offs then are the ones who are going to get the benefits and who have to endure the costs. Right now, in the certificate authority system, the one who gets the benefit is the operator of the site, and the one who has to bear the costs of the improved security is the certificate authority. And that's frequently actually why they don't do it, because the market effects don't really allow for it. So I'm of two minds about this. I certainly see the downside, but it has always seemed to me that in terms of how you align the interests, this is probably our best way forward.
Thank you, but I think another good example is the DKIM. The reason why DKIM is not widely deployed in China is that the DKIM is also heavily rely on the deployment of DNSSEC. So I think the big thing here is like the DYN or DKIM design is pre-designed with DNSSEC deployment prerequisites. So I guess that's the problem. Thank you, anyone.
Thank you.
还有问题吗？我刚刚忘介绍啊，现在 Andrew 是有新的身份，是 IAB Chair， 所以呢，我发现他很多问题回答都很长，故意躲避更多的问题。We noticed that you wear big hats now, and you are obviously avoid more questions with long speeches and answers. So I will turn to you in the open discussion session. Okay. 下一个演讲者我介绍的是来自北京邮电大学信息网络中心主任马岩教授他将给我们带来未来互联网技术与创新应用方面的报告我们欢迎。如果大家觉得有口渴或者是想吃一点东西，或者都可以去取，但是不要体积太大。
好，大家下午好。感谢主办方安排这样的一些活动，我也希望今后能有更多的这样一些研讨，不是光几位发言人在这儿，可能有更多的一些大家从广义从各个角度来考虑。因为我自己呢是在这方面工作了一段时间，今天大多数参会者都是咱们本地人，所以我还是用中文来讲。Welcome both of you to attend our discussion, and welcome for the more frequent visit to China. OK， 那给我的题目呢是一个命题作业，当学生当命题作业，说是讲讲互联网，讲讲未来互联网的发展。那当时也有一个选择，是不是讲点什么别的？后来说，哎呀，行了，就这个题目吧，先说一说我自己经历到的一些情况，然后呢跟大家分享一些我个人的一些观察。另外呢，也希望有更多的讨论，在会上和会下的这些讨论。那后面的材料呢，除了一页之外，大多数都是用英文的，所以我想，我还是用中文来讲解，但是英文画片呢，大家也大多数可能就能看得懂。想大家回顾一下简要的互联网的发展，因为说到未来互联网络，电信行业呢，我觉得还是比较聪明。First generation, second generation, 2G, 3G, 4G, 5G, 6G, 7, they can continue growing. But for the internet, then current internet, new internet, next generation, future, we have no word. 我们没有词儿来讲了，所以我想，不管怎么样，我们还是要看一看我们现在的互联网是怎么样发展的。然后呢，懂得历史能够创造新的。原来我一直是这样讲，后来上课时候我觉得可能不一定这个懂得历史有可能会受历史羁绊可能新的一些想法这种现在叫俗话叫跨界思考，可能跨界思考可能带来新的刺激，可能有新的一代人有更好的一些发展，一些发挥，一些自己对未来一些这种体验一些需求，包括互联网体系架构。今天咱们叫互联网体系架构，那互联网架构也是我们很感谢上一代人这个 John Postel 这样的一些老的一辈的研究人员和工程师做了很多前期工作，所以我们才能享受到现在的互联网。但是呢，刚才讲到Andrew 曾经讲到电子邮件，很多年轻人不用电子邮件了。老一辈的人，我们这种老头们还在用电子邮件，用 email， 但是新的一代人不用电子邮件了他们可能真的需要发明一些新的东西根据他们的这个需要，根据现在的技术的发展能够去创造未来去。所以我想，可能这个场合需要老头来念念历史，也需要年轻人来讲讲未来让他们畅想一下未来看到当然了，这个年轻人，我曾经年轻时候我要学，避免曾经犯过的错误这个能够更好的去发展未来去。所以这也说到了 migration 从4到6到未来这个发展我们能有更好的方法，从现在的这个大家不满意的地方，能够发展到今后更加满意的更加满足我们个人生活，满足我们机构发展，公司能够去这个有营收回来，然后呢，社会能够有更加这个发展，更加这个 无处不连从人对人连到人对机器连到机器对机器连Internet of Things、Internet of Everything 就来做这个事儿。另外呢，我见到的和经历过的一些研究一些应用等等的说一下。那这个呢也是老头们愿意回顾历史，也估计讲历史的也都是这个就这点经历了我想也希望有更多年轻人看到未来。老的历史呢刚才 David 这几天讲过了很多，就从 DNS 角度讲了很多，我也不再一一去回顾它。但是呢，我们来看一点这样的部分。这个部分呢，不行那不管拿这个来看。那我们现在是处在这个阶段处在这个阶段，那就是现在10年到20年这个阶段了。那么年轻人会在这个阶段去生活。我们也看这个阶段叫做未来互联网络。那么虚拟化可视化IPv6 DNSSEC 在我们这个年代。但是后来呢，再往后走呢，这个当预言家，刚才2位都说到了，当预言家比较难。但是呢，不管怎么样，大的趋势呢，肯定移动性这种 Internet of Things、Internet of Everything 这个大趋势大家应该是共同认可的。具体的技术实现细节会有变化这个以前做的不够好的会进一步完善DNS 会去完善 ，HTTP 呢也会从原来的这个系统1.0、2.0，HTML 呢可以从1.0、1.1、2.0到 HTML5有很多新的这样一些发展，所以适合未来发展。年轻人一定，现在新一代的人一定比我们老头子会要更聪明更能适应未来的发展这样我们这个你不管你愿意不愿意，这个时间总在过去那么新一代的人一定会有新的更好的办法。那不管怎么样，还是要再来看一看老的历史。那么我们现在目前的确是 so connected 到处就互联，而且你想不想你都没有办法逃离这个环境你都必须连在这个环境里头这个人呢现在已经号称有30亿这个人口互联的设备，互联在这个网络上面，设备呢更多。像我们学校日常注册的学生老师加起来不到3万人就是在校园内的校园外还要更多，但是在校内呢不到3万人。但是日常我们根据我们的网管监控到的数据呢，活跃的 IP 数大于3万现在设备数已经大于这个实际人的这个数量，所以这样呢也是带来的这个互联网的一些发展问题。从体系架构方面考虑怎么能够适应这样的环境。我们这个有些人就是在抱怨互联网这个设备不好，这个带宽不足这个贵。但是呢，实际想想，当年IPv4设计者在他们的环境下做出来的已经是最好的设计了所以我们看到这样最好的设计，它是有历史条件的。那么换了新的场景，技术发展了，连上来的设备更多了，业务类型更复杂了这个商业机会更多了一些想投机取巧、想在上面去搞破坏的人呢利用它去达到他自己的这个经济目的或者一些这种个人的或机构的一些目的呢，也有更多机会了。所以这个不是互联网早期设计的错误，而是当时这历史条件造成这么一个现状。那么我们现在呢也看到的确传统电信不再是传统电信了，没有传统电信了。中国电信都在说，我们的互联网营收大于传统电信的营收了。我们的这个公司不再是传统 traditional telecommunication 我们现在是互联网这个运营商我们的基础架构是面向互联网提供的，是面向移动互联网提供的基础设施。所以这样呢，这个规模的确是跟原来不可相比的。那么互联网架构 infrastructure 也必须要适应的往后去发展，也必须要考虑到现在和未来可能的3、5年甚至更远一点的。那作为 IAB 来讲呢，更是要从全局角度、全球角度来考虑整个这个体系架构怎么能够更好的发展到这个让更多的设备、更多的业务类型更好的这种盈利模式去发展，这个是 IAB 要考虑的一些问题。那么流量呢，也是大量的这个流量，原来小小的流量，我记得我当年85年的时候用光缆传19.2K，85年用光缆传19.2K，那现在呢，一根光缆一个波长跑这个100个 G， 跑400个 G，一根光纤里面可能64个波、128个波那个容量已经是飞速的增长。我们教育网 CERNET 做过统计，当年94年的时候是这个64K 的这个专线， 现在我们干线100G，已经是这种上百万倍、上千万倍这个容量扩展，大家还在叫唤不满足，的确是不满足。大家终端设备大量的这个高的性能提上来了啊，各种各样新的业务类型啊，还要求实时业务了，要求传话音、传通信了。真的，这个从过去到现在，我们要看一看，知道了历史，你才知道现在的出的现状，我们才能往后去看。那么V4呢，不管怎么样，还是要这个用相当一段时间。我们现在也有若干个这个机构和一些公司也在讨论是否这个要做纯 V6的。不管怎么样 ，V6的流量还在大规模在上升，在国内国外都在上升。应用类型呢，原来纯文字类型的，那么现在呢，大量新的类型的会这个逐渐的越来越多，深入到社会生活的各个领域。智慧城市啊、工业、农业啊、互联网加呀等等的东西。另外，大量这个 social impact， 当然以往呢是少数人在用，政府部门啊、这个研究单位啊、一些这个军用部门在用这样的互联网，很有限的，很受控的。但现在变成一个社会公共资源了，变成全球的通信基础设施了，已经逐渐从传统电信涨到互联网时代了。所以这样带来的更多的一些这样的机会呢，也是原来的设计者不曾考虑到的。那么我们现在呢，在考虑新的基础设施建设、新的体系架构时候呢，这些因素也都是不得不去考虑的因素。那么看了从过去到现在，我们再看看未来的发展情况所以一个是从过去到现在，从现在呢到未来，那规模呢，应该说看得见的这个50亿人口这个逐渐是不是会在未来的10年之内更多人能接上来？我昨天看的情况呢是，亚洲地区人口平均互联网的上网的这个普及率英文叫 penetration 中文我们叫互联网普及率是30%几，我们国家已经是40%几了，所以我们是大概这个5年来 CNNIC 统计的数字发出来挺好的，就是看到我们已经超过亚洲地区平均互联网的接入程度了我们这个今后呢，这个更多的发展中国家印尼印度墨西哥中国这样一些大的经济体和一些中小型的经济体，更多的会接到网络上来，所以这个设备类型更多，流量更大，这个覆盖的网络的范围越广这个更多应用会接上来那么这个命名刚才几位专家专门讲的命名，原来命名没有那么复杂，没那么复杂的业务没那么复杂的需求，但现在呢，由于这个技术的确真的当时Windsurf 也好Robert Carr 也好，他们几位早期设计最早是225分组交换，然后逐渐到 IPv4刚才说到了几位专家那么当时呢没有这样的需求，所以呢对移动性对这个位置和标识分离对这个域名系统的一些安全包括一会儿我们会说到关于基于内容的这种这个路由和基于内容的命名这样一些新的概念，可能都会逐渐从各个角度，从各种各样的需求能体现出来能让我们看到未来一些更好的服务于我们现在的人类社会的生活，服务于我们今后的发展。那么无线呢也更是这样的，有线无线的通信，原来没有80几年的时候这个没有无线的，没有手机的都是 walkie-talkie 大家按一下talk over 我说完了你再说一句半双中的模式。那么到了90几年，逐渐的移动互联网就是手机上的2G 这个 GSM CDMA 那现在3G 4G 已经在讨论5G 了，今天上午说到了5G这个实验室已经看到5G 的系统了，我们学校有做无线的老师也已经开始做实验，我们配合他们做相关实验，所以这些未来发展这个应该说我们是可以预期的这个是 predictable， 我们看到未来的流量类型呢也会更多，而且更多的实时性的一些业务会出现，服务质量大家更加关注网管能力呢也因为它指望它了，指望它就要去管理它，不管理就不能提供可提供质量的服务，所以必须要进入管理，所以管理的要求提出来了。那么能源消耗也是越来越厉害从芯片级的能源控制到设备级能源控制到应用级的能源控制到整个全系统能源控制越来越多的这个能源的这个消耗呢，大家关注，而且也不止一种能源，可能多种多样的能源这个都会去采集它包括我们会场，现在会场用能源还是比较麻烦，大家要去找个插线板，以后呢应该是这个桌子上用个无线插板 无线充电，你笔记本放那儿，手机放那儿，自动就充电很多新的这还是可预测。那么可视化我不再去细说，安全呢，这个 privacy 这个 protection 呢，这个 trust model 这个还要再说两句因为互联网治理这件事儿一直都在说，电信网是有治理。电信网是有管制是严格控制这个码号分配有一套体制。那么互联网呢也有，但是呢，相对来说，我看了一篇报道，说到这个计算机里面装那个病毒软件，工业界是不是换一个思路来想，不要在每个机器里装那个装防病毒软件，这个安全的模型能不能整个换一换这个 infrastructure 这个 total solution、total concept 要换一换，怎么换呢？他说。在这个现在人类生活当中经历的场景的时候，如果谁这个在商店里面卖假货，那就要有工商局去要管理它。你是注册公司你要有登记，你卖了假货，你就要受制裁。你害了人命，你让人受了伤，你要承担责任。那现在网上呢是现在互联网的架构，当时它是受控的环境。学校、政府军队系统的受控环境，他对这个没那么强的要求。但现在呢，谁都可以开发个软件，弄个病毒，我没让他到我机器来，他就到我机器来了。就这套认证的体制这套授权颁发的体制这个能不能这个在未来互联网体架构当中考虑这样一些因素这样呢，我们每发那么一个软件，我要一次certificate，我认可了它，我让它到我这儿来，我再到我这儿来，我不让到我来，我就不让它进我这个门儿。这样一些体制，我们设想未来的时候，好好思考一下，我们现在人类社会生活当中成功的东西哪些成功的，哪些用电子手段，哪些在未来的 cyberspace 里面能够去借重的能够去借用的，能够去发展的，这是我们要来思考的一些问题。那么因为今天话题叫这个 building block，building block 可能话题太广了这个哪个方面？这个都可以认为是个未来互联网的一个组成部分。那么，这个其中呢，我们说看到未来这个互联网治理这件事儿，也是我们building block 的一个，不只是从技术角度来看未来互联网，可能未来互联网的整个运作模式也要考虑，因为现在。今天中午我们跟几个电信运营商的几个朋友们在聊天，也在说，现在这个运营商遇到的这些各种各样的挑战，遇到各种各样的机遇怎么样能够这个我既有投资，我还能收回投资，我还能发展但是商业市场呢是竞争的，老的体制不适应的时候呢，它不能去生存下来，不能去发展。那么在这个有管理的这个竞争的话呢，相对来说让这个社会发展能够比较平稳能够。提供一定的，也制约了一定的这个创新性、创造性。但是呢，总体来讲，我们需要人类社会生活是受管理的，交通是受管理的，交通不受管理，随便横冲直撞的车就把你撞掉了。那么竞争环境也是要适度受控的。所以这样一些这个管理这个各个这个经济体economy 之间的关系在整个这个大的生态过程当中的关系，这些都是原来不具备的，原来互联网不存在的东西。那么现在呢存在了，我们现在需要去考虑它了，我们需要去大家去协商了，大家去这个争论了，大家这个解决方法了。我觉得技术呢要为这个我们的经营，为我们的这个生产来服务，而技术手段不能给我们制造麻烦像 P2P 这种东西就是 P2P 这种东西的确好用，但是呢它没人批准它就用起来了。用起来以后呢，把带宽用足了，他睡觉，他吃饭去了，带宽的一台机器跟着搭满了一个 G 在那跑把别人有效的应用全挡住了，就这种属于体结构设计这种属于体结构的设计。体结构设计说能不能有些好的想法能够在这个业务分级方面能够去给它一定的这个管理、一定的控制。它可以是滥占资源，但是你滥占资源，那你就要付出代价。就是这些从体结构上设计的时候呢，我想可能现在来考虑的话，应该是为未来的发展呢多一些思考，多一些这样的一些这个设计，能够让我们未来互联网发展的更好。当然，可能过5年、过10年不叫这个互联网了，叫个什么新的名词出来这个我们没法去预测。但是呢，这种思路呢，我们应该去预测，我们应该把这样的想法带到未来系统当中去。那building block呢，我不一一去细念，我们后面一个个再来看。那么这个再说点这个 real world and cyberspace 那么 cyberspace 到目前为止中文没有太一致认可一个翻译的名字，但是大家普遍认为呢，它是这个用这种电子通信的这个方式所生成一套新的一套这个空间环境。以往呢是说我有领土这领海、领空、外太空那么现在电子空间里面呢在我们这个 cyberspace 里面叫网际空间也好，叫什么空间也好总归它是一套新的一套机制。那么这套机制呢也越来越和我们的物理现实连了起来所以现在这个网络上经常看到一些论文征集的一些国际会议也说到了physics and cyberspace。这个里面的技术问题，这里的管理的问题，这里的一些法律的一些问题这里的基础设施的问题所以这些呢，好像都是我们在逐渐的从农业化社会进到工业化社会，逐渐的进到这种信息化社会当中这个我们正在处在这个门槛上我们现在很多人已经每天离不开看邮件离不开去看微信，离不开去使用互联网。那么这个时代呢，逐渐的会越来越多的这个人进到这个时代里去，适应技术的这个发展，能够为自己的生活带来便利，同时呢，为你的机构呢更好去发展。所以这样一些这个设计呢，我想这个应该说，这是无论是谁都希望有一个叫英文叫 prosperous， 我们都希望能有一个很好的一个发展，很光明的一个未来。但是呢，这些问题呢，需要我们一个个去处理。但体系架构上设计的时候，如果能考虑到一些因素的话，我们现在需求的确跟以前不一样了，所以我们根据现在的需求和我们预测到的未来需求，再来设计我们体系架构，我想很多问题会逐渐能有所解决。那么，这个说到很多这个头疼的问题，其实头疼问题呢，在这个动脑筋的人眼睛里面，它就是机会所以我觉得这样头疼问题，谁头疼了，那你是没看到机会你头疼了就应该看到机会其实刚才跟Andrew在说呢，我现在用我用了2个手机，一个手机呢是看那个微信的互联网手机大屏，然后呢大电池，然后呢开1天我能用不完它，然后话音什么什么上面都能跑，看个视频，干个什么事儿都可以。但是我还用了一个很传统的一个老手机，那个老手机至少有7、8年时间还在那用呢刘总给我一个那个新的一个手机也挺好的但是我觉得好像还是不能满足我的需求其实是个什么呢？就是大家都用这个名片交换到这儿来给我个名片，给我个 name card 但是 name card 来了以后呢，就是你看一看，然后你也能用这个扫描 scan 的办法把它装到计算机上，装到手机里，但是它还是个孤零零的东西，没有一个 link， 没一个 hyperlink 没一个东西把它关联度给它串成一个英文呢叫PIM Personal Information 这个 Manager 或 Organizer 一类的东西缺这么个东西，其实是个商业机会，人人都需要。我现在找名字曾经好像是老张老李叫张3、张4，我忘了。这时候呢，应该从好多别的关系上面我能把它追出来，但是现在你找的可是辛苦死了这整个这套东西，我觉得这要找机会，其实有很好的机会在里面。那这里面呢，体系架构这个我们有头疼的问题，它的可扩展性它的这个容量，它的这个安全问题，它的这个命名和路由的问题，它的协议的问题，它的服务质量问题，它分布式管理的问题，它的这种迁移叫 migration 或者 transition 或者叫这 upgrading 叫evolution 无论叫什么总归它是要任何老的这个有可能是彻底推翻的、彻底革命性的东西，但是呢。很多大量的这些东西基本不是革命性的，基本是要这个 building block 更换某1、2个 building block 那就可以。像移动电话，你说它是革命性的，的确革命性，但是呢，它又另一方面说它又不是革命性的，它就是打电话，只是说用内线拴着而已，用无线通信的手段，让你很方便的去实现人与人的交互，人对设备之间的交互，机器对机器的交互。但是呢，这个 building block 其中一个关键模块换了以后，给你耳目一新，给你带来全新体验，带来新的商业机会。那么，互联网的发展呢，我们也希望能有一个好的 migration， 好的这个 upgrading， 好的 transition。目前我们遇到头疼就是 V6， 大家刘总今天还跟我说呢，咱们辛苦了干了不止10年时间了，唱着 V6 好像也没太能弄起来。实际上就是设计的时候呢，对 transition 考虑不足所以我们在做新系统的时候呢，这个会考虑商业机会，同时也要考虑技术上的 feasibility。技术上的可行性能让它方便的从 老系统扩展到新系统，这个从这个原来功能不足的扩展到新的功能，这样的都是我们要考虑因素。另外呢，节能的问题啊，虚拟化的方式、可视化的互联网的治理和这个商业模型，可能这些因素，这个我们可能人还没聪明到那样子。你做任何一个设计，让所有的东西都能够满足，这是不存在的，永远没有 perfect， 永远没有一件事情是 perfect 的。人的寿命是有限的，你的设备你会老化掉然后你的协议呢会不满足新的需求，总是要 evolving 这个 evolution 或者 revolution 也好，总是 time goes on， time passes by， 我们总是要往前走去。但是这些目的最终回过来，我们是让我们生活更好，目标是让我们生活更好，让我们去做生意，让我们享受生活让我们去完成各种各样一些这个工作。所以呢，这些技术回过来也要去符合商业模式。目前很多技术的不考虑商业模式 ，P2P 是典型一个例子，他光顾着自己挣钱，没考虑生态环境。你又代替不了别人，但是你要去这个把别人的这个工作给压掉，那你自然自己发展不好，别人也发展不好。所以这样的技术要有商业模型服务，要为我们可使用的服务相关的呢这个管理这个治理这方面的 Internet governance 也是有助于我们的技术更平滑的演进，有助于社会的更好这个发展有助于全球大家互通互联来做这件事。那么讲到这个 architecture 呢目前应该说已经转了30年，超过30年时间。从刚才说到的82年、83年、84年我们现在到这个15年，马上就进说话5月份嘛，明年没过几个月就开始进16年，所以这样呢，这个体系结构呢，应该说是还是非常成功很多老的技术都更新换代掉了，但是呢 ，IPv4 不管怎么样，这个还是这个有些小变化。以前没有 subnet 以前没有这个这些这个复杂的一些这个管理控制没有 variable length 这样一些这个 IP 的一些管理。但现在呢 ，IPv4 已经不再是原来的 IPv4 了，已经有一些小的一些改进，但是呢不能满足。那么怎么去更新改造它呢？这个 clean slate 也好，是这个或者是这个 evolution 也好，比较平滑的过渡也好这个题架构设计的时候呢，可能也要考虑到这样的因素。你彻底的这个打翻掉，你就很难去在现在这么大的一个基础上，几十亿设备连的基础上面，能够快速的更新到新的系统上去所以这样一些这个设计思想，可能在考虑体架构的时候，也不能不去这个思考我们一些成功的经验和我们遇到挫折的一些东西，包括这个对微弱这个过渡情况。分层的这个架构和分布式一个管理路由体系这样一些东西，到目前为止还是基本上干活的基本还是工作还是可用的。但是还有一些变化目前体架构里面呢 end to end 很多 net， 上我说的internet NET 不是 NET 变成 NAT 了但是呢系统还在干活。刚才讲到 Skype， 然后跟 Andrew 讲到 Skype， 因为在 net 后面干活 ，Sim 呢额外要去，他也开发了一个这个 stand server他也可以去做，但是呢他晚了他在体架构初期设计的时候没有考虑到互联网演进成这种程度了，所以他这点受到制约而且呢他是一家做主，他不是多家做主的Sim 叫多家做主，大家吵架老吵不清楚这个 Skype 呢一家做决定，说做我就做了所以这样的一些因素呢，可能我们在这个设计体架构的时候呢，要容许多种各样的创新允许它去发展它。但是如果你这个 rely on one single vendor product， 那你这个你有 take risk， 你有些问题所以这是总是 always trade off， 没有一个东西是完全完美的东西另外呢，民主空间这个 address space、naming convention 这些呢，应该说还是有挺多的一些变化这个包括 inbound signaling model， 就是我们叫带内信令。原来电信网络呢是我有带内信令这个我也可以用大概性。更多呢，我们电信的王冠网专门有电信的王冠网，你这个话音爱通不通，反正你不通的时候你能通最好，你不能通的时候呢，我信令网还工作，我还能额外信号我去控制我的设备但是这个互联网老说这个电信网太贵。它不是有付出的呀，它是有保证的呀，所以现在回过来说，我要服务质量了，我是不是也要去做这个大概信令我是不是要去做control plane、data plane separation， 我要讲这个事儿了。我觉得很多事儿就是你看看历史，你回过来再来看看现在，这里面真的能多想一些事情可能让我们设计能更加有效一些。 那么这些都已经真正遇到很多挑战。那么这些挑战，我们能不能在我们新的这个系统设计当中有更好的一些这个有建设性的一些这个系统能力来做的？那么为了这样一些东西呢，我们全球各地做了大量这个实验网啊，包括巴西跟欧洲的这个未来互联网的实验网，然后呢中国跟这个北美之间的一些这个测试实验网啊，北美自己的实验网，这个中国自己的实验网，什么这个各个国家自己的小型实验网，各个实验室小实验网。不管怎么样，大家还是做了这个网上有很多文献，不再一一去列举这样一些文献，但是都是为了去架构的设计呢，再做一些思考。那从这个模型上讲呢，这个我们会看到有好多讨论了关于未来互联网。今天主要题目讲未来互联网，所以未来互联网有好多提议，包括 location-based naming、routing， 那是我们最早第一代。逐渐呢会有人提，是不是这个 location 这个叫ID 能不能分开它来做来那这样的话呢，我在一个地方我用几个设备的时候，我移动的时候哪些能跟着我走，哪些不跟着我走哪些这个业务跟着我，哪些业务不跟着我新的需求出来了，这些是要去考虑的。那么还有呢，这个张卫霞张老师呢，他也在这个做这个跟那个叫Jacobson 他们几位在考虑content-based naming当然还有其他一些研究小组也在考虑基于内容的也有这样的需求包括那个handling system 当然那个Robert Carr 几位 Dr. Robert Carr 他们也在做关于这个 handling system 希望能把图书馆的这个书籍我们的物联网上那些这个设备装备每个接口都有额外定义。我想把内容导到哪儿就导到哪儿，我想把东西存在哪儿就存在哪儿想把路引导到哪儿就引导到哪儿，很多好想法。但是这些想法呢，这个也遇到各种各样的问题目前还没有太这个统一的认识，大家还在探索。我们也是鼓励大家做创新去探索它。那么说到了这个这样的一些问题呢，就也要跟以往再比一比。以往呢，这个互联网以往的电信网呢是 intelligent in the core 那中心交换机一台交换机，当时我记得我们学校的一台交换机上千万这个万门交换机、程度交换机一台机上千万，当年的上千万，现在就更多的钱了那别人拿它没办法你只能去用它这个也不会有什么太多的这个安全，也会有些小安全问题，但不会有太多的安全问题。现在互联网呢，这个中心呢希望大管道透明传输没有太多智能在里面。但如果你要去做了content 的这个 routing 的话 ，content naming and content routing 的话，那你就要求有些智能在里面了要有 control 在里面了你要去做相关的 authentication 你要去做 distribution 你要去做各种各样的 caching 做很多的东西，那它要做很多的计算，很多的信用网络又做得复杂了，所以这是一个螺旋式上升的一个过程怎么样能找到最佳的一个点目前我觉得还没有看到太满意的这个解决方案在里面所以这个很多这个系统结构呢，如果我们看看以往，再看看现在，回过来再发现提的问题呢，人家在那个场景解决了，在新的场景不适应了，我们怎么能在新的这个场景里面呢，这个发明一些老的东西，再利用以前的一些好的一些成果，这个呢是更有助于我们快速的能够实现我们一些设计目标。那么说到这个可扩展性这个图呢也是昨天晚上看到，今天早上那个谁也在用这个也在用这样做the same chart 然后这个目前呢应该说各 IR 已经在这个有非常快速的包括对 ARAN 没有最后的 last/8 policy， 这样的话呢，按照目前的这个分配方法的话，我估计按照 Jeff Hughes 的那个算法，估计在今年下半年快了，今年下半年慢了，明年上半年基本会没有掉了所以这样呢这个未来会不会能更快速的启动，让这个可扩展性问题能得到解决呢？这个还在讨论但是呢，会有越来越多人认为，不管怎么样，在没找到更好的方法之前，6还是一个解决方法所以现在我经历到的一些运营商、一些内容提供商也对这个感兴趣，觉得这个事儿我们既然拿不到地址，如果再去买地址的话，这个能解决一些问题，但是后面再买不到怎么办？还是不行于是那样不如想想看看能有新的招 但是转成6好不好呢？转成6听起来挺好，但是也有这些问题。这个没有经过实践检验、实践验证，觉得小规模还是可以，但做大规模以后怎么样？这种翻译的设备能不能解决问题？新出现的协议它能不能顶得住？我觉得不要怕，还是努力往前冲，你要去做，要去实践，能够去解决这样一些问题。所以不管怎么样，北美的主要的内容提供商已经开始来做了。现在百度IPv6点百度.com 实际上走北欧，走我们这儿提供的线，因为现在运营商没有提供，所以他们找我说没问题，我们给你们提供做实验，做商业你去找商业服务提供商，但是你做实验，我们绝对支持你们，配合你们一块儿来做。所以搜狐这个新浪等等的，我们跟这个腾讯的几个公司都有一些联络，希望能够帮助这商业公司来做，包括几个CDN 的厂商，我们跟都有一些配合，希望能在这个可换性问题上面能得到一些好的一些解决方法。6呢，全球的统计数字这个应该是快速的增长。国内呢，这个相比来说还是慢了一拍，其实也是个 vision 的问题。如果你要想不仅在我们这个现有的业务当中，而且你要开辟新领域，而且不只看着我们这片地区，我们看到更多地域的时候，像更多未发展的地区的时候，其实是有机会的，其实还是个眼光的问题。而且很多账上，其实我自己觉得不应该算在6的头上你本身设备要更新升级，你更新升级的自然带上来功能，买的设备已经没有不是6的设备了，你的应用的操作系统早就都支持了但是总是把账算在6的头上，很冤枉。其实还是他们自己没想清楚。当然了，也有一些公司的政策，他们也说，那出了问题，引入新业务不稳定，赖我的 KPI，赖我的用户抱怨，这不行。所以我想可能还是公司政策这个要去做一些调整以后，能让新的业务其实为他们自己好，他们自己公司业务去发展。那容量问题呢也是不再细说，反正总归是大规模增长，1个 G 400个 G 1个 G，现在400G 的实验系统都出来了已经在用了，我们也是一点逐步在做这样的实验，干线的这个实验开始快速的扩展。未来互联网一定是高性能的这个大家去抱怨带宽不够这个网速不够，其实是我们暴涨这个跟不上来。你现在我们20年走到这一步，你再照着全球有几个这样的国家20年能做到这个样子几亿人口，现在全球第1大互联网的用户能够在20年内走到这个样子，我说电气工业还是干了非常多的工作才能走到这一步。然后呢，接入网络无论是有线的、无线的接入网络，肯定也会形成的越来越快。数据中心这个可能是最快、最早上100G 的这个接口的这个单位逐渐大规模提供高性能内部的数据交换，做云计算做这种 data center 这个做这个 search engine 各种各样的数据中心里面大量的高性能的东西。end 设备end device 最终终端用设备也是这样的。你现在随便一台笔记本1个G 的接口随便一个这个3G 4G 的手机这个都是几个 G 的这个无线通几百兆甚至几个 G 的这个上行的这个能力一点点会逐渐越来越多我们会见到这样的，所以对干线的压力是越来越大。那对这个互联网来说呢，由于互联网不停的创新，所以呢才有了今天的这个繁荣从原来最早的纯字符的，然后到语音到视频的交互性的大量的这个智能化设备 IoT 的这个设备逐渐的软电影网络开始冒出来。所以呢，未来互联网里面体系架构当中，可能也是一支这个叫我管它叫生力军也好，是它能不能成功？但是不管怎么样，它还是挺大一个力量。我们现在见到大量的设备厂商在那真的不再是做实验了，真的开始卖设备了。我的设备我接到这个邮件，接到这个朋友电话。戴尔的、惠普的，然后国内的一些什么各个厂商很多这个华为华3什么好多厂商都在那说，我们有这个SDN 的设备上来了。那么 SDN 呢，我自己觉得有很多功能其中一个很重要的特征就是它是开放。这个开放呢，能力开放，然后业务快速部署，然后呢什么这个系统更加灵活，的确是。但是呢，开放带来了所有的东西，如果不开放，带不来所有的东西。所以有了这个开放但是它也带来一些问题它这个相关的情况呢，我们来看那对协议来讲呢，如果 SDN 来做这件事的话，它也一定要这个可操作性，要互操作性，要 SDN 要做的一定保这个互操作性，无论它是 ONOS 也好，是这个 OpenFlow 也好 OpenDaylight 也好，不管怎么样，它一定要有这个互操作性，没互操作性就没有现在的互联网。所以呢，对协议设计的时候呢，无论你自己公司的产品，你要 公司产品自己你要互操作性，你要想变成全球性的产品，没有一家公司能全球打天下所以它一定要去做这个标准化，一定要能够这个做全球的可互通性全球的互操作性，要来做这件事儿。所以呢，在设计协议的时候，可创新的机会还是很多。所以我们今天题目叫这个互联网这个刚才给我名字叫什么来着？对，互联网基础设施是吧？和应用创新。那协议其实创新的机会真的很多。现在我们用的应用层的协议创新，传统层的现在也在做 TCP 的、XCP 的、SCP 的，很多新的这个传统层的一些协议也在改进在无线场景下怎么去应用它，大存储量情况下怎么用这个10个 G、100个 G 最基础时候 TCP 怎么去更新改进它，它的窗口怎么控制它的时间怎么控制，它的状态切换能不能做一些这个调整，做一些简化，很多新的一些这个创新机会在里面。网络基础设施网络层的协议 V4、V6，我们还会可能出现这个CCN NDN 还能出现新的，可能过一段时间还有更多的一些这种网络层的创新出来。物理层呢，那也是现在见到所有的打工的性能提升这个各种各样的这个互通互联在短途的、长途的有线的、无线的，其实很多新的创新的协议创新的机会在里面。那么这个说的安全那么有了这样一些这个系统以后呢，这个大家人人都来用，那就会商业利益，会有一些组织的一些机构的一些利益，或者一些政府的一些利益。那么这里面呢，从传统电信来讲呢，相对来说它是这个封闭的，也有一些漏洞。协议设计呢会有一点点小漏洞发现一些漏洞。那么设施的工程 engineering 这个 programmer 他也会犯错误另外呢，在部署方面在 engineering 部署方面 deployment 的时候呢，也会有些漏洞，但是相对来说，电信网的漏洞还是可信的。所以大家一说电信机质量电信机的安全这个词儿呢，可能我不知道国外是怎么叫，反正中国人是这么叫这电信机的质量是好的。那么互联网呢，相对来说到目前为止，路由器还是相对比较有关封闭的华为这个 Juniper 这个 Cisco 等等这个 Alcatel 不多的几家了。现在数出来全球骨干网的路由器现在真的不多了，没有几家了。但是它的能力呢，被它封住以后，大家觉得我没有机会了。我想感知我的包转发的时候，我感知不了；我包处理的时候，我没有办法；我要预约资源的时候呢，我没有给我接口。很多的这压力呢，应用层希望了解底层的拓扑结构，了解它转发过程，理解它的优先级想预约各种各样的资源，没办法。这样呢，这个 SDN 就开了这么一个口子它允许说，我拿个白牌机器，我自己灌软件，我自己去写东西去，的确带来业务快速部署，的确带来方便，的确带来开放。但是相对来说呢，目前的结构呢，对安全也有一些考虑，但是总体来讲呢，这个漏洞也越来越多这个机会呢越来越多机会多了，那肯定有各种各样一些这个漏洞会藏在里面。所以应用层呢，目前为止是个 open space 是人人都有机会，我随便编辑应用，反正我也不用认证，我也不用去要 certificate， 我就编辑软件一个病毒随便网上就发了这个一个点放出去以后，大概一夜几万台、几十万台机就传染出去了。以前是单文本的，大家一定要个硬盘，有个 USB， 有个什么软盘 floppy现在没 floppy 了老头儿念 floppy， 老头儿念软盘3层半什么5层半软盘。那现在呢，有了网络以后呢，非常快速就扩展出去了。那么 SDN 呢，的确在网络层开了一个门不仅在网络层开了门，同时呢，它控制器在这个控制层上面，它也允许是这个各种各样的这个叫 servlet 各种各样一些控制器的这个控制软件这样的控制软件呢，可能以后也会去上这个 store 叫这个控制器的一些小插件。能够去上这个商店去，大家可以去订购，可以去开发自己做，这样也带来各种各样的不安全性、不稳定性和这个不可信性所以软件应用网络其实也是这方面，我觉得讨论呢，应该说相对来说还是关注人不够多。我们希望这方面一个体系架构上设计的时候，如果不考虑这个因素，那是给自己找麻烦的东西所以这个方面我觉得还是要认真去思考它。另外呢，这个。就整个安全和隐私保护，整个体系架构呢，在未来互联网体系架构设计当中也是非常重要的。我们不可能指望一个人设计一个全面的、所有的解决 total solution， 处理所有的事情，但是一些基本的规则呢，还是要去考虑。这样的话呢，至少有些指导原则、一些 guideline 能够让这个大家有规有矩可循能够去遵守一些基本的一些规则。另外呢，从体制上讲，如果不做这件事儿的话，那是给自己找麻烦的，这个我们是要去避免它。那么，未来互联网的研究呢，工业界很多机构，那么学术界呢也有相关的一些这个单位在里面在做标准化组织，这个 ONF 也好，是这个其他一些机构也好标准化组织，这个不只是新的标准化组织，传统标准化组织IETF 也好，是这个IEEE 也好，很多一些标准化组织也都参加到新一轮的这个互联网体系架构的这个演进过程当中来。工业界更是这样的。那我列了几个研究机构，各自做了一部分事情，但是仍然不能覆盖所有的这方面的研究进展。那对于我们自己来说呢，我们自己也是希望能够给学生们提供一个好一点的一个这种科研创新的一个体验的一个环境和经历。这样呢，我们也跟欧洲跟北美很多研究机构联合来做的。我们曾经也是在举办了一些的这个参加了一些的活动能够去跟厂商，那么跟这个标准化组织跟这个各方面的一些这个研究人员建立一些环境，让促进学生们去了解目前互联网的演进了解目前最新的技术，培养这样一些人呢这样一些新一代的研究人员和这个工程师呢，为整个行业呢能够多储备一些知识，储备一些技能。那这个我们也在这个除了在我们校内之外呢，我们校际之间也在促进这样一些互联网应用创新的一些机会我们也有大学生的这个 SDN 的创新和应用编程大赛我们去年办了1届了，今年准备再办第2届。去年大概有200多个团队今年可能有更多的团队。同时我们也会去这个逐渐积累的经验以后呢，这个能够有些国际合作也邀请国际上一些研究团队呢、一些同学们、一些学生们能够加入到这个创新环境来。我们也鼓励同学们看到国际上的这个领域一些最新进展能够参加国际上的一些这个应用创新能够在使用互联网的同时呢，也去体验互联网的真正的内涵真正它的这个价值同时呢，把自己的创意、把自己的理念呢编到应用系统当中去但是这样的话呢，也需要有很好的一些指导，给他们提供一些环境能够帮助他们来从事这样一些研究工作和这样的编程实验工作。我们自己也在校内呢搭了一个实验环境，能够这个支持同学们和各个研究组呢跟工业界结合来做一些研究工作。目前我们这个环境里面应该说这个还是搭了有1年多2年，将近2年左右的时间。学校呢给我们一些支持这样我们跟企业呢结合，连了有7、8个实验室有4、5座楼这个已经有一堆实验做了一些实验，也开发了一个实验验证环境，能够去上面去预约资源，能够去监控这个实验的进展的情况进行一些资源的调度能够做一些业务统计这个实验呢列一部分我就没有去做翻译这个多个实验室开展了实验研究，包括软件定义的虚拟运营商、服务对比这个移动 IPv6 的切换多终端协同智能光网络双向感知广播风暴这个对比实验呢做了一批相关的一些实验。可能我们后面还会再找一些新的一些研究课题，希望能够跟行业相结合，解决行业的实际的问题，而不再是纯空设想的一些东西，而是能解决互联网遇到一些问题，希望来做这件事儿。那么时间有限，不再去一张一张详细去解说。对我们是说永远没有理想的环境，那我们应该是这个在研究环境当中呢，跟这个各方多加联合、多加配合大家共同来促进互联网的这个发展，能够从过去的网络到我们现在的互联网，然后到未来互联网的演进当中呢，跟大家一起配合，能够获得今后更好的这个研究成果，更好的服务于社会。好，谢谢大家。
谢谢马老师给我们的精彩演讲讲了我们这边 IPv6 还有未来互联网的一些这个发展趋势和要点，包括他这个很长时间的这个经历，把这个 Internet history 跟我们再回顾了一下，看还有什么问题，大家可以提一提。 我这边哈，其实在 V6方面也是一直有很多这种工作呀，或者一些会有自己的一些观点。那现在在我看来哈，那个问题提给马老师，也提给 David 研究，就是 V6现在在发展的过程中，我发现了它有一种跟 V4一种竞合关系，就是有竞争有合作。合作在于它要 transition， 它要依赖 V4，那它需要 kernel， 需要 translate。那竞争在于它在争夺用户资源，比如说你的笔记本，比如说你的路由器的 TCAT， 比如说你的 website 你是推 V6还是推 V4 的 content。所以说就是在这个过渡的过程中，我们应该从技术的角度和从 policy 的角度应该怎么去引导，或者是怎么，比如说从 IR 的层面，或者从 ICANN 层面，或者从 ITF 层面，还能做些什么事情能够推 IPv6 在这个过渡过程中的一个处境？那就我知道的话 ，ITF 已经有Behave 工作组已经关掉了，然后 Software 工作组也就快关掉了。所以说，在 ATF 这一块，我比较失望的在于从技术推动 V6， 好像 it seems to be very hard。And so， 那请问这个 V6 有这个 V6方面经验的专家能够给我们一些这方面的建议？
我自己呢，两个身份，一个身份是学校的老师，另一方面呢，我也参加IPNIC 的一些工作。IPNIC 呢，作为全球5个主要的这个 IR 来提供全球的网络用户的地址和自治域编号和这个反向这个运营解析这种工作呢，这个培训啊，也支持当地的互联网发展呢，专门来做这个。所以各 IR 呢是很努力的，能够去推动互联网这个发展。这个发展呢，一方面是 Vixie 发展，另一方面呢，看远一点呢，看基础设施的这个更新、升级、改造特别是为发展中国家这个不断的经济上的这个发展和在互联网呢更多的接入能创造新的一些商业机会方面呢 ，IPNIC 做了大量的工作。所以我们在地址分配方面呢，只要你去申请这个 V4的地址，这个肯定会对应的会这个分配一大块这个 IPv6 这个地址。那么这样呢，促进大家不要去为了为了 V6额外你还要再去做一次工作，还要再额外这个费用额外还要再去经过相应的手续，能够帮助大家在互联网基础设施的升级、更新、改造方面呢，会给你做很多这样一些工作和促进工作，包括在各个地区来做这个网络的地址的管理和这个业务的这个部署和这个网络的安全和对当地的经济的一些发展。我们还有一个 IPNIC 还有一个叫资助项目叫 ICANN 互联网应用创新基金这个项目，其实也是在亚太地区的这个公司也好、学校也好、一些机构也好，他们有好的想法，能够用 ICT 技术促进当地经济发展能够去促进改善民生这方面呢，他们每年都在国际上面吸引很多一些资助一些这种企业和一些国际机构给一些这个funding能够让这个发展中国家，特别是亚太地区的发展中国家，能够来利用这样的机会去发展他们自己互联网的这个教育培训和新技术这个演进和各种一些创新。所以我想这是从 IPNIC 角度来看到对这个 IPv6 这个发展。另外 IPNIC 也有自己的 lab， Jeff Houston 是一个 Chief Scientist 首席科学家，他在全球的这个互联网的这个地址的和业务量的统计分析方面做了大量的这个持续不断的工作能够提供一些这种数据分析呢，给大家来判断和了解全球和所在本地区的这个发展呢，提供一些技术素材。同时在很多别的一些研究方面呢，也能够这个促进 V6在这个协议标准化方面在各种各样的新的一些创新方面呢，很多一些工作。 所以这方面我想从 ABD 角度是希望能够在互联网的发展当中呢，其实不只是看V6，V6是现在这个阶段的一个重要工作之一更长远的是对整个互联网在全球这个经济社会的发展当中发挥重大作用来做的各种各样的努力。另一方面呢，我是在学校里工作，学校呢，北邮是教养的一个叫 founding member 也好，是叫我们一个主要的这个成员单位也好。目前我们是这个4RNet 和4RNet 2、4RNet 2的backbone node 的一个 chain center 这样我们学校 V4呢，目前我们学校之间的这个信息交换流量这个有几十个 G。V6的流量呢，我们也是在全国，在教育网里面好，在全国觉得应该是目前是最大的。日常10 G 的流量 ，V6 的纯 V6的流量就打满了，日常就打满了。我们现在升级了20个 G， 大概现在跑到这个15、16个 G 上面去了。所以这方面呢，我们对学校的科研和学生的各种实习、各种创新呢，提供好的实验环境以后，能够去促进这方面人才的这种发展和各种技术的一些这个利用。同时，我们跟运营商去做各种的配合，包括刚才说到的IPv6百度.com 这些网站的一些通道，这方面我想也是希望能够在这个领域呢继续促进这个互联网技术的发展。V6只是手段之一但是是目前阶段非常重要的一个环节。如果没有的话，因为我们运营商很多朋友也在聊，他们也说头顶这个地址不够我们也遇到一些新启动的一些这个运营商、一些 ISP 一些云计算公司一些各种各样的一些这种机构，确实地址真的没有那样呢，如果再去用这种 NET 技术去做，不是说不能解决问题，但是会很痛苦而且呢，对咱们长远发展来讲，还是会有很多的问题。所以我们也希望在这方面呢，通过我们前一段的这个积累，包括在V4、V6的转换，在 V6的网管，在 V6的安全防护在这各种业务部署，在这种这个新的一些这种人员的一些培训、网络的管理这方面，我们北邮愿意在这方面跟行业的各方面的人士做很多的配合，支持大家去在互联网方面得到更好的发展。谢谢。